brings goosebumps while hearing our national anthem. So, collaboration is important, not just because it's a better way to learn, but the spirit of this collaboration is a part of equipping yourself for effectiveness, problem solving, innovation, and lifelong learning in an ever-changing networked economy which we are facing nowadays. And what could be more electrifying than to have all these ignited minds meeting on this common platform, the ACR Trends 2023-24. So respected dignitaries, honorable guests of honor, honorable chief guests, and all the invitees, a very good morning to good evening to everyone. See, the energy is that I'm feeling like it's morning now. I, Roshni Godbole, on this occasion of ACR Trends 2023-24, welcomes you all on behalf of our family of Indian Society of Heating, Refrigerating and Air Conditioned Engineers, that is ISHRAE Pune chapter. ACR Trends, the tagline says, know what's currently trending in HVAC and R, is the forum of choice for learning and networking in an interactive and crisp way through dissemination of technical knowledge and techno-commercials on latest HVAC and R technologies. And we are proud today to host the 18th edition of ACR Trends, which has always been a flagship program for ISHRAE Pune chapter. So we at ISHRAE foster innovation to deliver the best possible solutions in the field of heating, refrigeration, and air conditioning engineer and related sciences while guaranteeing continual education, career guidance, and financial assistance through various initiatives. And ACR Trends is the germination of this ideology, and you all are a part of it. So it is indeed a beautiful evening, right? And all soaked in this delighted frame of mind. And to grace this occasion, we have with us with our distinguished speakers, industrial delegates, and all invitees. So I once again welcome you to this mega networking event. Now, just आपली एक परंपरा असते नेहमीची लॅम्प लाइटनिंग सेरेमनी, कारण आपण दिवा लावल्याशिवाय पुढचं काहीच शुभ कार्याला सुरुवात नाही करत. So the beauty and significance of light has been focused from thousands of years ago. Physically, light gives us strength and radiates joy and happiness. And spiritually, it gives us a sense of hope, love, pride, and peace. So I now request our President of ISHRAE Pune chapter, Mr. Nandakishore Kotkar sir, National President-elect Mr. Anup Balani sir, RD West 1 Mr. Manish Gulalkari sir, ISHRAE Presidential Member Ashish Rakheja sir, Past President of ISHRAE Pune chapter Mr. Mukund Ranade sir, Immediate Past President of ISHRAE Pune chapter Mr. Virendra Borade sir, Convener of today's event Mr. Subhash Khanade sir, and ISHRAE Presidential Member Mr. Arvind Sunge sir for this lamp lighting ceremony. you so much, everyone. As this lamp burns brightly, may it remind us of the eternal flame within us, our inner strength, and also as a student, your inner strength becomes our strength, right? So thank you, everyone. Now moving on, I request the gentleman leading this mega event, ACR Trends, Mr. Subhash Kanade, sir, Managing Director, Atharva Energy Solutions, and an active member of ISHRAE Pune for more than 14 years, and also the convener of this event to enlighten us about the further proceedings and evening ahead. So please.
Thanks, Roshni. So good evening all. I'm not getting the energy. Good evening all. So to witness such a mega event and national event, I wish we should clap for ourselves. We are witnessing the same. Thank you. So honorable chief guest of today's evening, Mr. Balani sir, all stalwarts of the IPC, consultants, all past presidents of the IPC, office bearers of the ISHRAE Pune chapter. So I'm Subhash Kanade, as a convener of this evening ACR Trends. I welcome you all. And being a convener of these technical events, it's my honor to officially welcome you all for this 19th edition of ISHRAE Pune chapter's mega national event ACR Trends. Actually, we must thank to one person, that Mr. Suhas Deshpande sir, who has started this ACR Trends way back in 2006. And what plant he has planted, now it is taken a tree shape. So thank you, sir. Each and ACR Trends grows in importance and now becoming a national event. This is a pride to ISHRAE Pune chapter that this is, we are celebrating this as a national event. For this, we are fortunate to have a galaxy of stalwarts with us, like Mr. Balani sir, Mr. Gulalkari sir, Regional Director West 1. This year, ACR Trends theme is Go Green, Go Smart. And as the theme, we have intellectual speakers too. So we are thankful to Mr. Mukund Anade sir, a presidential member of ISHRAE, will speak on misconceptions of psychometry. Mr. Ashish Rakheja sir, a presidential member of ISHRAE, will speak on energy-water nexus. This is a really new topic to all of us and will add value to us. You know, we have conducting this ACR Trends. It is a good blend of technical speech, technical talks, and product presentation too. So I know you will enjoy all these things. Before we kickstart the conference, I would like to express my sincere gratitude towards all my CWC members who have taken hard and contributed largely to make this event successful. As a convener, I promise you that today this is going to be a great evening of inspiring, learning, motivating, connecting, and networking. So thank you very much, and without taking you much time, let us start the program. Thank you.
Thank you, sir, for the overview. It indeed is a task to organize such an event at this grand scale. Thank you. I now request Mr. Nandkishore Kotkar, sir, President of ISHRAE Pune Chapter and Managing Director at Ashapuri Refrigeration Services, Bibwewadi, Pune, to throw some light on the activities of our Pune chapter.
Thank you, Roshni. Ladies and gentlemen, before moving ahead, day before yesterday, our past president, Mr. Satish Menon's son, passed away due to long injury. For that, we are going to silent for 1 minute. So I request everyone to please stand. Om Shanti, Shanti, Shanti. Thank you. ISHRAE Pune chapter is doing back-to-back events. As of now, near about 80 plus events we have already done. Even today morning, the national event Shakti was fantastically arranged, done by our team. More than 300 plus members was present. It was witnessed by HQ team also. So now we are moving for this ACR trend, and I would like to say we are going to arrange another some few big events like Satsang and Green Conclave in mostly December and February. So tomorrow there is one IEC program that is on kitchen ventilation. It is venue at our ISHRAE office. So let's participate all the events and encourage our CWC team. So on behalf of ISHRAE Pune chapter, I again welcome all of you, and I request to our ACR team to start the event. Thank you. Thank you, Vana.
Thank you so much, sir, for the overview. So moving on, now we have an address by our guest of honor, Mr. Anup Balani, sir. But before that, I would like to just give a brief about him. With 42 years of experience in the air conditioning industry, his leadership roles in two prominent air conditioning companies reflect his profound expertise and commitment. His contributions extend beyond corporate success, as he has held national positions within ISHRAE, including the prestigious role of National President-elect. His wealth of experience, industry acumen, and dedication to advancing the field make him a notable figure in the air conditioning sector. His current role as National President-elect further underscores his commitment to driving innovation and excellence within the industry, cementing his legacy as a significant contributor in this domain. So I now request Anup Balani sir to kindly take the charge. So let's welcome him with a big round of applause.
Good evening, everybody. I was reading that thing over there, the schedule which they've given me, and they gave me 20 minutes. And then I saw the time. This program was supposed to start at 5 p.m. and we are already, what, 50 minutes late. So I thought that let me catch up with some time and get back there. So I won't take more than 10 minutes. So just, because I don't have, I showed my PowerPoint presentation this morning about what's happening in ISHRAE and what's going on. I don't think so. This team needs that because majority of you people over here are ISHRAE members. Am I right? Yes. There you are. So you don't need it. So what you need is what's new things happened in the ISHRAE in the last couple months. So I'm just going to focus on those few things. Of course, when I thought that let me talk about what's currently trending in HVACR, and when I saw two stalwart names here of Mr. Anade and Ashish, I said, who better than them about the current trends of HVAC? I'm nobody in front of them. So we have two big stalwarts sitting here, and of course the other ones like Mr. Pranjpe, then all like the senior people sitting out here, all the white-haired ones. I've lost my hair, so so I'll leave it for them to talk about the trends, and I'll just focus on what's happening in ISHRAE. So just to let you know that in the last 6 months, or I would say 8 months, ISHRAE's eye, though we're keeping it eye as Indian society, but that eye is moving towards the international side. So we've opened chapters in Bangladesh, Dubai, and Qatar. And we are in process of opening chapters in Bahrain, Nepal, Nigeria, and Kenya. So we are truly going international. So we'll have, hopefully by end of this year or maybe middle next year, we'll have over about 8 international chapters. And just to add to this, you won't believe Dubai sub-chapter, we call them, when they open up, we call them a sub-chapter, and then later on move them to a full chapter. Dubai and Qatar, these 2 sub-chapters, though there's a lot of Indian diaspora there, so working well, Dubai sub-chapter has already crossed 150 members. So we are doing and there are some technical local regulations which are stopping us to, increase the number of members over there because of formation of the chapter, and some technical glitches are coming, commercial glitches are coming. Otherwise, we have people, lining up who want to become members, but the only question is that we are not taking members because we have to service them also. And that is becoming a little difficult task because of the commercial glitches which we are facing. But hopefully in the next couple months we'll be able to resolve that also. Similarly in Qatar also. Qatar we've got over 100 members already. So we never realized that ISHRAE, when it goes international, or we are so much in demand in this part of the world also. So that's one part of it. And just to update you, the latest in this society year of Yogesh, which is, we are 2/3 of the year over, we've already increased our membership by 5%. So we had a target of 5% and we've already got 5% new members all across the country. So we've touched our target already, and we are aiming that we'll be closing by about 7 or 8%. So that's a new add-on. Then in the government field, I think Ashish will throw more light on it, that of course the ECBC or ECSBC, we were given the opportunity by the government to write the codes for the ECSBC, and we achieved it in the time frame. Am I right, Ashish? In the time frame given to us by the Bureau of Energy Efficiency. But they've given us another task now. And the latest task we have is to update the National Building Codes HVAC chapter. Am I right? The HVAC chapter. And again, Ashish has taken up that task, and he's going to form a task force. And again, it's a time-bound thing. So what this is telling us is that the government is recognizing ISHRAE to moving in that direction. So we are achieving things on the government section also. Now coming to the president's theme, the president had announced 2 themes in his tenure, for this tenure. One was decarbonization and other was skill development. Now we had an unfortunate episode in ISHRAE in the beginning of it, so the president was a lot involved in that. So this decarbonization and skill development things got taken a little backseat for the first 4-5 months of the year. Now he's taken them up on a full swing. And just to give you an update, decarbonization task force under the leadership of Mr. Pankaj Dharkar has been formed, and there are about 4-5 senior members who've been made in that committee. And the first step which they have thought of taking is that they are going to prepare a presentation which is going to be a basic presentation. Cities like, I would say major cities like Delhi, Bombay, Calcutta, even Pune or Hyderabad, and the big time cities and the people in the big time cities, the members really do understand what is decarbonization, but decarbonization being such a big, vast field, people down the line, the chapters which we have in the tier 2 cities, chapters which we have down the line, basically do not know what the meaning of decarbonization is. So we decided that we're going to make a small PowerPoint presentation of about 10 slides, and the first step is in the next 4 months is we are going to educate within ISHRAE, the chapters, what really is the meaning of decarbonization. What do we mean by decarbonization? What is our pledge of decarbonization? So that's the first step which we've taken, and hopefully in the next week, 10 days, this process is going to be started. Second thing is about skill development. In skill development, just want to update you that there is of course, we've been in talks with the Skill Council of India. We've been in talks with the ozone cell, and they've all told us to prepare programs for dissemination of the knowledge for technicians. And again, as a matter of fact, the president, along with a team of 3 people, met the Rata people and the Rama people, and we are trying to shake hands with the 3 societies, where ISHRAE will be the arm which will make the technical, should I say, material, and Rata and Rama. Rata will bring in the technicians, the people who have to be trained, and Rama is the one who's going to do coordination with the government, and hopefully we may have a certification program which will have ISHRAE and Skill Council of India's logo on it. But it's too early to say that, but ISHRAE certification program is definitely going to happen. Just to add, there is a society, there is an NGO in Delhi called Shakti. Now, that NGO has given us a task to train 5,000 technicians, and we have taken up that task. We are going to start that training in the next about 15-20 days. The course content is under process, and so we will be training 5,000 technicians maybe before end of this 2023, and move on in that direction further on. So I'll not take a lot more time, and that's all is the update for ISHRAE front, and thank you very much, and let's have a great evening today. Thank you.
I now request Mr. Nandkishore Kotkar sir to kindly felicitate Mr. Anup Balani sir. Thank you so much, sir, for the briefing. I now request our Regional Director, West 1, Mr. Manish Gulalkari, sir, to take over the mic.
Good evening, ladies and gentlemen. Good evening, Pune. So मला सकाळची आठवण झाली परत एक सुरुवात झाली ढोल आणि ताशानी याच ठिकाणी आणि जबरदस्त एनर्जी आणि ऊर्जा होती आणि तीच एनर्जी आणि ऊर्जा अजूनही मी मेंबर्समध्ये पाहतोय. सो दॅट इज रिअली व्हेरी व्हेरी पॉझिटिव्ह साईड. सो वी स्टार्टेड द डे ॲट से अराउंड 8 o'clock and now say after 10 hours or 12 hours the same energy is there, That is really, really appreciable. That is point one. Again, yesterday there were actually 8 chapters installation, student chapter installation. Today, two back-to-back event, morning Shakti and now ACR train. Tomorrow again, there is ICP on kitchen ventilation. So this team is doing incredible job, excellent job. Being a RD, I know how much efforts this team has put last 3 months for both the events. Really excellent example of teamwork. Let's give a big round of applause to this entire team. Sorry. So after the grand success of women program Shakti, we all are gathered here for one more mega event, that is ACR Trends. Yeah, so I know this event right from the day I joined actually ISHRAE, maybe more than 15 years, I think 18 years now. Great opportunities for the new, great opportunities and techniques on the technology of HVAC industry. And of course, it gives a superb networking platform. One good part about this event is every year the speakers are world class. Once again, kudos to Team Pune for the selection of excellent speakers every year. Today, we have with us outstanding speakers, Mr. Mukund Ranade, and our own Mr. ISHRAE. Personally, I am very eager to listen to both of them. So without taking much time, I will hand over the mic to both of them. Wish you a very happy learning. Thank you so much.
I now request Mr. Ashutosh Joshi sir to kindly felicitate Mr. Manish Gulalkari sir. Ladies and gentlemen, moving on, it's now time for the most awaited presentations, the sessions which had grabbed the attention for many days. More so because they are to be delivered by our distinguished personalities. So we now have a plethora of idea and product presentations lined up for today. So let me call upon our distinguished speaker, Mr. Mukund Ranade sir, who did his master's in thermal engineering from IIT Mumbai in 1978, worked with Kirloskar Pneumatic in their RAC division, then shifted to AC projects and was design in charge for largest air conditioning job in India, namely International Airport, New Delhi. Then he worked with Thermax Limited and retired as General Manager R&D. He even developed world's first lithium bromide based double effect chillers working at 0 degrees Celsius. From 2009, he shifted to corporate research and development team looking after waste to power as well as solar air conditioning. Currently, he's working as a consultant. He is also a visiting professor and project guide for MTech courses at Pune University campus. He was president of ACR Western India chapter as well as ISHRAE Pune chapter. ACR USA has recognized his original and distinctive work in the refrigeration and air conditioning field by awarding him status of ACR Fellow. So he would be briefing us about the topic misconceptions in psychrometer. So let's welcome him with a big round of applause.
evening to my friends. Today's lecture is actually on basic psychrometrics. Now, I can see some of the raised elbows because ACR trends is not for teaching basic psychrometrics. Basic psychrometrics is for students, at the most for trainee engineers joining companies like Blue Star Voltas or something like that. So why Mr. Ranade is coming here and talking about basic psychrometrics? The reason is when I go to various sites or various meetings and I meet, let me be very specific, senior practicing engineers, I find there are very common and many misconceptions about psychrometry. So today's lecture is actually not to tell what is psychrometrics, but what are very, very common misconceptions in psychrometrics. That is what is the today's lecture. So I will start with the first one. Before that, the whole thing is based on two books. कुठे करायचं, इकडे करायचं, इकडे करायचं. Where to point? So that the whole thing is based on two books. One is Understanding Psychrometrics, ISHRAE publication, and of course our very well-known ISHRAE fundamentals. So let me start myth number one. Absolute humidity. So the myth is y-axis of psychrometric chart is absolute humidity. So many people take this y-axis as absolute humidity, and I am saying it's a misconception. So what are the units of y-axis of psychrometric chart? It is a kg of moisture per kg of dry air or grains per pounds of dry air. What is the ACR definition of absolute humidity? Absolute humidity is the ratio of mass of water vapor to the volume of the sample. So the units of absolute humidity are kg per cubic meter, and of course, hence, the y-axis of psychrometric chart is not absolute humidity, but it is humidity ratio, which is of course defined as what we understand, that given W of a given moisture sample is defined as ratio of mass of water vapor to mass of dry air in the sample. So we understand it is that, but we call many times as absolute humidity. Sometimes people call specific humidity. Specific humidity actually by ACR is the ratio of mass of water vapor to total mass of moisture and not the dry air. So the absolute humidity, again I am repeating, so the y-axis of psychrometric chart does not denote absolute humidity but humidity ratio. About relative humidity, second myth is about relative humidity. Most of people say relative humidity is the ratio of mass of water vapor present per kg of dry air at certain pressure and temperature to mass of water vapor kg of dry air when air is saturated with water vapor at same temperature and pressure. This is what many people call as relative humidity, but it is not so. Actually, that is degree of saturation. How does ACR fundamental define degree of saturation? Is the ratio of humidity W to humidity Ws of saturated moisture at the same temperature and pressure. So what we call relative humidity is actually degree of saturation. And how does, what does Understanding Psychrometrics also book says? Many people and some texts incorrectly use definition of degree of saturation as the definition of relative humidity. So they understand that there is a difference and people misunderstand. So what is the definition of relative humidity? Relative humidity is the partial pressure of water vapor present in the air divided by saturated partial pressure. And of course, there is the equation they give between the degree of saturation and relative humidity. But how does that figure? If I take at 0% and 100%, both are same. But if I take 50% at 40 degrees, if I call RH as 50%, the humidity mu is 48.1%. So what we say 50% is actually 48.1% or vice versa. So actually we are meaning that RH is 50%, but we call it as 48.1% or something like that. Okay, but now what happens? People say, even understanding psychrometrics also say that at the down, the problem with the incorrect, understanding this book also says, the problem in incorrect definition is that many people or textbooks also consider RH as NWS upon MWS. But what happens is, when I call PW upon PWS, partial pressure, people don't get a feeling. They say, hey, what is partial pressure and that is, how does it make a difference? I don't get a feeling about it. So to get a feeling, the best definition is the most common definition of relative humidity. If we say the same definition, mass of water vapor present divided by mass of water vapor that can be maximum present, but instead of per kg of dry air, if we say for same volume, then it is exactly the relative humidity. Now many books say that, but they don't explain how it is that. So here is, so we can say relative humidity is the ratio of actual mass of water vapor in a given volume of moisture to mass of water vapor in the same volume of saturated. But then we say that you say so, but how it is true? Whether it is matching with ACR definition. So that is very simple. If we say we have unsaturated water vapor, so PW we call as unsaturated water vapor. PW is equal to VW into NW into R into T. And we have fully saturated water vapor at same temperature. That is PWS into VWS into MWS into RT. And now we have said for the same volume, so VW is equal to VWS. So if we divide both of them, then MW upon MWS is equal to PW upon PWS, which is the ACR definition. So if we say per given for the same volume, then we get a feeling also, and also it is the correct definition. Next misconception is about dew point temperature. Many people say the temperature at which condensation of moisture just begins when air is cooled, or the temperature at which the first drop of liquid water will appear when air is cooled. That is what people call as a dew point of the air. But this is misconception. ACR technology of heating ventilation terms and definition, there is a book which clearly says it is improper. It is improper to refer the dew point as temperature at which condensation starts to occur. Because condensation at dew point requires removal of latent heat from the vapor to induce condensation, and this can occur only if the vapor is cooled below dew point, maybe 0.5 degree less or 0.4 degree less. So if you want to say what is dew point, the definition given by ACR is almost same but slightly different. What does this understanding psychrometric of ACR book says? They define dew point by two people. One is lay person definition. Now I don't think practicing engineers are lay persons. So for lay persons, they have said the same definition as what we say in misconception. But we are not lay persons. When we are doing practicing engineers, we are not supposed to be lay person. So the ACR fundamental definition is the temperature of moisture at a pressure P with the same humidity ratio W as that of given sample of moisture. So when you reduce the temperature and when air becomes completely saturated, not come out, but completely saturated, that is the dew point, and not when the first drop comes out. So that is the another misconception about dew point temperature. One more misconception is about enthalpy. Now, let us say I have two airs where the wet bulb temperature is same and dry bulb temperature is different. Now, people always say that if I have, let us say, 50-degree dry bulb and 20-degree wet bulb, and another air at 21-degree dry bulb and 21-degree wet bulb. And people say that wet bulb to same hai, but since dry bulb is higher, either some people say that the enthalpy is same because it's almost, but some people say same nahi rahega, 50-degree temperature ज़्यादा है, तो enthalpy थोड़ा ज़्यादा होगा. That is what the misconception about the enthalpy is. But actually it is reverse. At 50 degrees and 21 wet bulb, the enthalpy will be lower than at 21 degree and 21 degree wet bulb. So it is exactly reverse. So common sense, people will say that 50 degree dry bulb and 21 wet bulb, the enthalpy will be higher. But actually, if I have 50 degree dry bulb and 21 degree wet bulb, the enthalpy will be slightly lower than 21 degree dry bulb and 21 degree. This is the common sense ke against hai. First, let us see whether it is right or wrong. Whether Ranade is saying that doesn't mean it's true. What does the psychrometric chart says? So if we see a psychrometric chart, this is the line of red line is of enthalpy and the blue line is of wet bulb. So if I take 50 degree and 21 degree wet bulb, this is my point. Then I can just go here and read here as enthalpy as 60, where I have given here somewhere enthalpy 62. 62. And if I want to find 21 degree and 21 degree and point, so near I cannot see it really. The dots are from here. If I want to see 21, then this is the point, and then the enthalpy is almost 62.1 and 60. So there is a higher enthalpy if I have got 21 dry bulb and 21 wet bulb. Then the enthalpy, दिखता है क्या? So the enthalpy will be lower for 50 degree dry bulb and enthalpy will be higher for 21 degree and 21 wet bulb. Now, we understood it so, but why? The answer is very simple. When we have, in the thermodynamic wet bulb process, when we have 50 degree and 28 degree wet bulb, let's say I have taken a little different, and then at the end, we are supposed to get 28 degree and 28 wet bulb. This is an adiabatic process, except the water enthalpy has been added. So the left-hand side is H1, and right-hand side is Ws minus W1 into HW. So there is a slight increase in enthalpy at 21 degree dry bulb and 21 degree wet bulb as compared to 50 degree dry bulb and 21 degree wet bulb. So understanding that dry bulb temperature ज़्यादा है, wet bulb temperature same है, तो enthalpy ज़्यादा रहेगा is a wrong. Next myth is about air density. People feel that if I have same temperature, let us say 34 degree and 4 grams of moisture, and air B is 34 degree and higher moisture, let us say 21.7. So dry bulb same है, pressure same है, लेकिन moisture ज़्यादा है, so people say density of air B will be higher. Again, common sense, but it is exactly reverse. When we have more moisture, the density will be lower. So first let us say from psychrometric chart what Ranade says is right or wrong. So if we say here, the figure was given at 30 degrees centigrade, lower moisture. If you see the specific volume is 0.875, and if we see higher moisture, the specific volume is 0.9. Specific volume is 1 upon density. So if we see here, the lower portion has 1.14 density, and the higher moisture has a density of 1.11. So, I'm sorry, exactly other. Air A, where the density is higher, where the moisture is lower, and air B, where the moisture is higher, the density is lower. Now, we have understood from psychrometric chart what Ranade says true. But why? The reason is the density of moisture is dominated by the density of air has come down. And if the partial pressure of dry air has come down, that means there will be overall density will be lower. So the misconception that more the moisture, more is the density is wrong. The next misconception is our psychrometric chart. People say all psychrometric charts are same, but it is not so. So let us say a ACR psychrometric chart. As you see here, this line is slant. And if you see the next chart, this line is vertical. So there are generally available two types of psychrometric chart. This chart is drawn on dry bulb versus W, that is humidity ratio. And ACR has drawn the psychrometric chart of enthalpy versus humidity ratio, and not dry bulb. And that is why dry bulb line need not be exactly vertical. So there are two types of charts. One chart is ACR is taken enthalpy and dry bulb, enthalpy and humidity ratio, while most of the manufacturer chart like train, carrier or Carol, those are mostly T versus W charts, and that is why this particular line is perfectly vertical. I think we started little late, so next one I will skip because I take from Mr. Balani that because next two are going to require little bit more time, so I will take last one. This I will skip. Now next two misconceptions are difficult to put in one line like I have put earlier. And hence it is given in the form of question. If there is no misconception, answer is very easy. So, the myth about wet bulb temperature. The teacher was teaching the cooling tower, wet bulb temperature, etc. And he told that at no load, if you assume that pumping horsepower is negligible, then the minimum you can reach is the wet bulb temperature. You cannot go below wet bulb temperature in the cooling tower. That is what they were told by the teacher. There was one bright student and he raised the hand and said, I don't agree with you. So he said, why you don't agree? So he says that the air which is coming to the cooling tower is every time new air is coming to the cooling tower. And the new air is unsaturated. It is hungry for moisture. So let us say 28 degree and 35 degree and 28 degrees the air is coming. Already we have achieved 28 degrees because I am running for say a lot of time and I already achieved 8 degrees. Now the new air is coming over here, which is also not saturated. So if this is not saturated air, some of the moisture it will absorb. And some of the moisture when it will absorb, the latent heat taken for that particular vapor formation will be taken by water itself and the water temperature should reduce. So he argued with the teacher that I don't agree that minimum temperature can be wet bulb temperature because every time the new air is coming, it is undersaturated. So it will definitely, some of the water will go into it and the heat required for vaporization will be taken from water itself and the temperature should go down below the wet bulb temperature. That is what we agreed. So that is the question. So we all know about wet bulb temperature. There is a delta T as you see on the right side top and we call it wet bulb depression. I do not want to explain, but basically we know that it is because the air is unsaturated, some of the moisture from the wick goes in that and the amount of heat required for becoming liquid to water is taken by there and we get that wet bulb depression. This is all known to us. And we also know that if the air is more and more dry, we get more air depression. So all of us practicing engineer know it very well. But still we don't know what is the answer for that student's question that why doesn't go below wet bulb temperature. So we all know that heat transfer depends on delta T. That means if there are temperature difference is high, the Q will be high. Everybody knows that the Q will be high if the delta T is high. That is for sure. Similarly, the mass transfer depends on K into delta P. What is that delta P? The saturation, suppose this temperature is 30 degree, whatever is the whatever is the steam table pressure or corresponding to 30 degree or saturation pressure, that is P1, and that is partial pressure is P2. So that delta P is nothing but P1 minus P2. More the P1 minus P2, more will be the depression and more will be the mass transfer. So that is all we know about it. But what happens is, now let us say we just started the process. We have a wick where the water is there and we started the airflow. If we assume that originally the temperature of a wick was at that point and the air is coming new every time, its partial pressure is same. Because for 2 minutes or 3 minutes, the partial pressure of air is not going to change. So this datum for potential is going to be remain same. But as the temperature of wick will start going down and down and down, this potential delta P will start reducing. So पहले suppose 30 था and wet bulb suppose 25 है, so 29, 28 आएगा, तो the partial pressure and वो difference कम हो जाएगा and the mass transfer rate will reduce. So as the wick temperature falls down, delta P starts reducing the mass transfer rate. The rate of dropping of mercury in the wet bulb thermometer will be very fast at the start and will reduce as the wet bulb wick temperature starts going down. Now let us see balance of heat and mass transfer rate. So as the temperature in the wet bulb thermometer starts dropping, we know delta T is generated. But as the wick temperature falls down, because of this delta T, the moist air, suppose this becomes 29 and air is coming at 30. So it sees that the wick is at 29. So it starts heating also the bulb. So what happens is, moist air at higher temperature will start sensibly heating the wick, and more is the drop, more is the sensible heating. So what is happening? Mass transfer is trying to lower the temperature. Still, some of the water is going in the air and the heat required for making from liquid water to vapor is taken from the bulb, and that is why the temperature is trying to go down. But at the same time, the heat transfer is trying to increase the sensible heat is trying to increase the temperature. So initially the mass transfer force is very high, heat transfer force is very low. As the temperature drops and drops from, mass transfer force goes on decreasing, heat transfer force goes on increasing, and at some point both the forces exactly match. And when it exactly match, we call it as a wet bulb temperature. Of course, I have not added radiation in that. That also takes place for simplicity. So there is some radiation force is also there. So now we know what student was missing. Every time the new air is coming, the new air is taking some moisture along with the cooling tower water. Because the moisture is going in the vapor form, the water is coming, latent heat from water is going there, so the temperature of water is trying to come down, but it is being sensibly heated by dry air at 35 degrees, and when both the forces are matching, the temperature remains same, and that is why we cannot go below the wet bulb temperature. So people, most of the practice engineer very well know that it goes below because of the humidity difference, but most of the engineers are missing this heating force, and that is why I thought that this misconception I will clear during the lecture. The last misconception I am just showing one figure from ACR fundamental. There is one example. It is not important what is the example, but they have shown the dehumidification process. And if you see the dehumidification process, they have shown the curvilinear line. What they have shown is a curvilinear line. We are all used that the dehumidification process is the one straight line. So this is, but why it is curvilinear line? We know that it is we always draw it as a straight line. But why it is curvilinear line? Because suppose there is a 4-row coil. So the first row mostly will take the sensible cooling. The first row mostly will take sensible cooling, and that is why it is more horizontal, because sensible cooling. It will take some latent cooling also, but it will take more of a sensible cooling. So it will be slightly horizontal. And as you go more and more deep, it will start becoming more and more vertical. So first of all, let us understand that it is not a straight line as we see. But still, in psychrometry, there is something called straight line law. Now, what does the straight line law say? That this is a 4-row coil. 1, 2, 3, and 4. And this is the ADP. So this is the 4-row coil, and they have shown the process. What is the process of D, 2, 3, 4? That is the process which is not straight. But we normally take the process as D, F, and ADP. Why so? Because of the straight line law. What does the straight line law say? That it is definitely there that there is a sensible cooling as well as there is a latent cooling. But what is unique is that the rates of heat transfer and mass transfer are so related that the 4th row, that is point F, always fall on the straight line joining D and ADP. So this is different, but this point will always lie on T, ADP and D, and that is why it is very convenient for us to show it as a straight line process. Now there is a big derivation available to prove this law that, so if we have 3-row coil, suppose I have 3-row coil, so then this point will shift down and again it will fall on the straight line process. Whatever is the last row, if it is 8-row coil, whatever is the last row outlet will always fall on the point D and TADP, and there is a derivation available for proving that, but in between points will be always curvilinear. So this particular kind of misconception is not very clear to the people, and that is why I asked this question in the form and not in the statement form. Now, at the end, I want to give one puzzle. This is almost, my lecture is almost finished. So I am just giving one small puzzle. I don't expect you answer during the question answer session because it may take a lot of time and already we are delayed. So it may take a lot of time. Already we are delayed. So just think about this question. Maybe you can write to my email if you know the answer. You can write to my email. So at the end, I am just giving one small puzzle. You have many times gone while boarding in the aeroplane in the monsoon season. You have seen that you will see the fog coming from the grills or whatever the outlet. You have seen many times that the fog coming from the grills. Now, why the fog comes? Because in the monsoon, the plane is on the ground, so we are taking fresh air, so we are somewhere here. And the ADP is here. So ADP is here, say 10 degree. So we are somewhere here. So the coil outlet point is somewhere here, which is the fog region. So this is not a puzzle. This is a situation, and the puzzle is coming next. Now the puzzle is, now this is kind of a super saturated solution of water. Now how we have defined the dew point? We have clearly said the dew point is the temperature when the air is fully saturated. Now, when I give this fog and it gets some sensible heat, or sometimes we have to give this sensible heat in reheat form, particularly in the HU, where you want low humidity, when the air comes like this, we give the strip heaters or any other heaters to increase the temperature. So initially when the temperature slightly increases, say 1 degree, half degree, 2 degree, then what will happen? Whatever is the fog along with it, it will go in the air itself. The fog which it attached to it, now the temperature has increased. So the air can absorb that moisture. So the moisture will go in the air. What does mean? The dew point we define that when the air is fully saturated. So when the air is getting fully saturated, when I am heating. So is the dew point, normally we say dew point is lower than what is the operating point. But the puzzle is the dew point more than the operating point in this case? I don't expect answer in the question answer session, but I hope you are clear the question that we have a fog region, we are heating by reheater or we are getting by sensible heat, and after getting some sensible heat that air has gone and become now fully saturated. So is the dew point higher than the temperature at which we are seeing the air? So with this small puzzle, you may answer it by email or something, because in the next slide, will the dew point temperature of the point A will be higher than dB or of A? Will the dew point temperature of point A will be higher than dB of A? That is the puzzle. And you may write to me in my email msranade@gmail.com, and I think that with that I will close. I know it is not the AC trend, latest trend, but unless your fundamentals are absolutely clear and there is no misconcept, you really cannot do the new trends, and that was the purpose of my giving this lecture. Thank you very much. Thank you, ISHRAE.
Hello. Thank you so much, sir. I now request Mr. Anup Balani, sir, to kindly felicitate Mr. Ranade, sir. Ranade sir is full of energy, right? Whatever, yeah, he should be expecting with a big round of applause for him, because the presentation was really nice. He has also delivered his lecture series in our college as well. So from that time I know him, and he's actually a good speaker. Thank you so much, sir. And now I request Bhushan Marde, Managing Director, Cosmos ADP, and founder with having 34 years of experience in HVAC and our industry, to take the charge of the session.
Good evening, friends. It is really a difficult task for me to deliver a technical presentation after Ramde sir. I don't know. Thank you. I'm not here to discuss about, this product VAV, what we are using currently, and I'm here because this product, now we were listening to the earlier speakers and the recent trends about power consumption, about green building, about sustainable projects and all, everything. And wherein this product has come into picture, where now we have tried saving power from high side, we are now saving power from the low side. So that is the reason now if you see any project, any centralized AC system where you have a centralized air distribution, VAV is a standard important feature of that project. So what I'm going to discuss about here is, because everybody knows about what is VAV, we know what we were using earlier, that
it was a CAV air distribution. It is more of a constant air volume air distribution with variable supplier temperature that we used to use in old days. But last 2 decades, when this product has come, now we are using VAV air distribution, that is variable air volume air distribution with constant supplier temperature. So, it is vice versa. So, I don't have to discuss what is VAV for you and the principle of VAV. But there are some, this product has come in last 2 decades. Everybody has started using it. It has become a standard feature. But it is like, you see a good batsman come to an Indian team and he performs well for some time, and all of a sudden he loses his form because some technical error comes in his technique, and then he starts getting out and he starts not scoring hundreds what you expect. That is what has happened to this product. Currently, if you see all the projects, whatever are happening, you will see VAV is main product, but why we are using VAV is to save power, and second part is to give comfort to the occupant. These are the 2 main goals of the system. And what is happening here is, because of some misconcept which is crept in VAV designing and the project designing, the second part, theoretically, power saving is done on paper, everything is done. Consultants put a lot of effort designing the project. But what happens finally is that, if you see the recent trend, that wherever the VAVs are, the occupants they are not getting comfort. They are not in comfort zone. We don't put occupants in the comfort zone because they are facing mainly overcooling problem. That is a standard, if you talk to anybody, many of the big clients, and they say, why VAV boss? We get a lot of discomfort, we get overcooling problem. I'm setting temperature at 24 degree and it is going 20 degree, but still the VAV is not working. Is it the VAV not working or what is wrong? So I want to discuss this point because this product is very close to my heart. We introduced VAV manufacturing in India, and what I find is it is being abused. That is the reason I'm here, actually. See, in VAV, you see this. There is a controller. There is a controller, and there you see those blue and red tubes, which are taking the signal to the controller. And then in front, if you see there, you see the crossflow sensor, which is the important part of the VAV. Pressure-independent VAV has got very important role to play in air distribution because it knows it has got a certain airflow range and it has to play within that airflow range and control the room temperature. So once any VAV, for any zone, any cabin, any room, you decide a VAV size, you decide as per the air quantity requirement. Based on that, you check the nominal capacity or nominal flow rate of that VAV model, and you select that model. That is the normal concept. But what has happened? One more thing. So in pressure independent VAV, the important feature is to read airflow rate. Pressure independent VAV has to read airflow rate precisely because there it notes its Lakshman Rekha, the limits maximum to minimum. So the important component here is the cross-flow air sensor. So where the problem lies, importance of VAV sizing. This is the most important thing which we should now focus on, because if there is, what is ideal throttling? You have the damper which has to, if you size the VAV box correctly, then the damper will use its complete rotation. It actually rotates 90 degree. The damper actuator, the damper flap will rotate 90 degree, but for you it may be from, ideal throttling will be from 85 to 0. So that much of that much of travel should be there. It will happen only if you size it correctly. If you don't size it correctly, then what happens, maximum time, the VAV damper will be closed for giving, and then the total operating cycle, it comes down to very, 20 degree, 30 degree, or maybe 15 degree. And it is very severe throttling, and that creates a lot of problem. It will be a noisy unit. It doesn't end here. Right. The common misconception is that the oversizing of a terminal will make the unit operation quieter. In reality, the terminal damper will have to operate in pinch down condition most of the time, which may actually increase noise level of the space. Control accuracy may suffer as the terminal is only using fraction of its total damper travel or stroke. In addition, the low inlet velocities may be insufficient to produce readable signal. Now this is very important, readable signal for the sensor and reset the controller. If the controller is not reading air quantity accurately or precisely, it will badly affect its performance. How? This means minimum setting may not hold with resultant loss of control accuracy and undesirable hunting. The recommended selection for maximum performance is to the size the terminal's maximum flow limit for 70 to 85%. This is very important of its rated capacity. The inlet velocities of the VV for maximum air quantity should be around 2500 ppm. Why? I will come to that. See, now I'm just using a case study for you to explain what my point. Normally for any cabin, if it is 480 CFM, the heat load, whatever heat load work out, 480 CFM is air quantity. There is a tendency, because in the cabin there are always bosses, finance director, this director, very important, there is a MD, so usko thanda kar do. Add more 20% air. That is the general trend. Right? So what happens now? It was 480, I've added 100 CFM to it. So CFM jada de do. What I've done. So now what are my options? Because for delivering 580 CFM, I have to select my VAV. And so I will go to the manufacturer's nominal capacities. Based on that, if you see 150 inlet size, the maximum capacity is 520 CFM and minimum is 100. For 175 inlet size, it is 710 and 140. But 175 is hardly used by anybody in the market. So people will go for 200. See, 520 is not suitable here. Actually, it was suitable, but since we have gone to 580, now we have no option for other than to going for 200 size inlet size, where maximum capacity is 925 CFM, minimum capacity is 185. These are the rated capacities. Okay, how it will work now? So inlet area is 0.3 square feet. The rated capacity is 925 CFM, minimum is 185. Set airflow rate is 580. This is what I have to, because I have decided 5 is my maximum air quantity. So 580 CFM and minimum is 100. 20% of that or 15% of that. If you theoretically work out, the maximum velocity pressure for 580 CFM will be 48 pascals. And for minimum, that is for 100 CFM, it will be 1.4 pascals. No pressure sensor of any VAV package, control package, will read that. Now there, the controller becomes blind, dumb, and it will start hunting. So what will happen, instead of delivering 100 CFM, it may deliver 200 CFM. It may deliver 175 CFM. It will not go below that, because it is just finding for a right signal, which it is not getting 1.5 pascal, it is not readable. That is the reason those VAVs do not add to the comfort of the, it is not, they do not deliver the comfort to the occupant, but ulta, they are going to create miscomfort by delivering more quantity than what it is required. This is my problem. So what is the solution for this? I had shown you the theoretical calculations. Normally, the VAVs, whatever manufactured in India, cross-flow sensors are not capable even delivering, even giving you 100% signal. Whatever theoretical, whatever you worked out, it may not be even that. It may go down below that. So what is internationally done is they amplify the velocity pressure signal. The velocity pressure signal is amplified, and this is the way it's amplified. So what happens? If you see, the theoretical, it is, for 150, it is 118 Pascal for the maximum air quantity of that rated VAV. But with amplification, now I'm getting 398, so increase of 335%. Similarly, if you go to Vmin, which is very important, that is 3.5 Pascal. Theoretically, it was 3.5 Pascal, but since it is amplified, it is reading now 11.9. So my VAV controller is able to read the air quantity. This is very important factor. So I'm not getting into this. So what we should be doing is we should be using a VAV. We should be able to amplify the signal. Unless it is done, your VAV is not going to perform at minimum air quantity, and that is going to be a problem. It is going to bring miscomfort to the occupant. This is the point which is missed by everybody. Generally, there is a trend to oversize the VAV. Oversizing will increase the noise. Oversize will increase this. You will face this problem. You see, majority of the projects, I am involved in hundreds of jobs. We have installed more than 100,000 VAVs throughout India and globally. And we see the problems in India, what we face, especially in South, that the VAVs are oversized. And the user, the occupants are facing the problem of overcooling. So this is the point which I want to make. I can go on and on because I am here. For me, this is a very important product. We should be there. We should be there in your design concept. But whenever you design the project, please take care of this. Thank you.
Thank you so much. I now request Mr. Chetan Thakur sir to kindly felicitate him. Thank you. Now we have Mr. Harshad Patil from Nihal Enterprises, our society for the presentation. Nihal Enterprises is a Mumbai-based firm working in field of air filtration, air disinfection, odor abatement for the past 18 years. So let's welcome him with a big round of applause.
Good evening, friends. I will straight away go to the topic. We are basically into the field of air filtration and air purification, disinfection through these couple of technologies, electrostatic filters, then we do a lot of work in UVGI, bipolar ionization, PHI cells and ozones. So basically all these technologies, we have different systems and products to deliver clean air or to indoors or outdoors. These are some of our products and the brands which we deal on. Electronic filters for dry scrubbers, Rider brand. Then we have electronic filters for air handling units, which are again Rider. Then UVGI system under UV Pure. And then these products again, two brands. Iron Pure is our own brand which we manufacture the units in India. And for ozone system, we are connected with a company called Chemtronics. They are also manufacturing the units in India. So these are the products. So these are just the photos. These are products from Rider. Similar products we have for our own made in India products, which are UV systems, PHI cell, ozone generators, ionizers, etc., etc. Now I'll just start with the technical presentation. The topic today is basically dry scrubbers. These are very predominantly being used for treatment of exhaust air from kitchen. So I'm covering that topic, dry scrubbers for kitchen exhaust. These are some of the points we will cover. Important parameters for selecting scrubbers, proper installation, how not to install, servicing, and some introduction for high-rise buildings. So basically scrubbers are basically filters, dry scrubbers, and they will follow the laws of filters. Like when you have got higher velocity, you will have more pressure drop. When you have higher velocity, you will have less efficiency. Or you have higher collection area, then you have more life of the filter. So all the filter laws are applicable to dry scrubbers. So there are a couple of important parameters which are to be considered while selecting a dry scrubber. Most important, number one, is the collection area. Because many times what happens is you get, like when you select a HEPA filter for an operation theater, you don't go by the box size, 2 feet by 2 feet by 2 feet. Basically the first question which is asked is, what is the collection area? Same applies to the dry scrubbers also. So generally an international norm is about 1.8 square meter of collection area for 1000 cmh of air quantity. This is a good engineering practice based on what a lot of manufacturers internationally supply. Okay, if you select a filter with less collection area, it results in lot of cleaning requirements at site, and it can be really a very big nightmare for the clients because they have to maintain the unit for 8-10 years, which is a very important point. Second important parameter is the face velocity or cross-sectional velocity across the filter, because as I said, this is again a filter, and for any filter this is an important point. So optimal selection is at around 750 fpm, and it must be backed by ACR DOP test. Like at ACR DOP test 750 fpm, the unit should show a efficiency equivalent to MERV 13. So if it is MERV 13 and 750, that means you are selecting the right product. And third important point is the contact time. Like when air, these cells are very deep, about feet deep. So when the air passes over the electrostatic filter cell, a minimum contact time of about 0.1 seconds is required so that proper filtration happens. Another important are of course certifications, like for chillers we have ARI, or for fans we have AMC. So these are the various things which are available for scrubbers. One is a completely UL listed dry scrubber, which is not really been used in India, but it is available, UL listed dry scrubbers. CE certification, which is important because these scrubbers, as we all know, deal with very high voltage. The inside voltage is 12 kVA and 6 kVA. So these certifications which show that the product is safe for use at site is very important. And as I said, ACR DOP test should reflect efficiency of the scrubber at various velocities, and one can select the proper scrubber. NIOSH is a field test. Unfortunately, it doesn't happen in India, but in a lot of developed countries, this test is conducted at site to see the efficiency, actual working efficiency of the product. This is a typical system. This is a duct coming from kitchen and the duct going to the fan. The scrubbers get installed in between. The opening is always on the side, so you have access to remove the filters for washing. So basically first is the pre-filter, and then second is the electrostatic filter. This can be removed, washed and put back. So this is a typical installation, and power connection is available on the scrubbers. For on-off switch is available, indicators are available. This is the main part, electrostatic filter, which is inside. This one is the electrostatic cell. So this is the heart of the product. So this is inside. Here, as you see, there are, first is the ionizing section, and back side is the collection plates. So that's what I was referring to, the collection area. The product, what air quantity it can handle will depend on the number of plates and number of ionizing sections. This is some good installation photos I will clear so that how to install a system. So this is basically a typical, this is not a kitchen actually, this is a for sun and shave and all manufacturing unit. You can see the scrubbers are installed near to the hood so that the oil doesn't get carried over. The fan can be anywhere in the system. Post the scrubbers, your duct will be clean. There will be no oil or anything, which reduces the major risk in kitchens, which is the fire risk. So important points, as I said, ceiling suspended, clear space in front of the units for servicing. If you see, there is a typical frame installed for ceiling suspended unit because the doors should open more than 90 degrees. If the suspension rods come in between, then the door won't open and the unit servicing won't happen. So this is a typical good installation. This is another kind of installation on terrace where the units are connected individually. Again, you can see a proper plenum is done, proper service space is provided. Another installation where you have got bigger system, so we make a plenum, connect to the scrubbers, again make a plenum and connect it to the fan, and the air is thrown out. So these are some good installations where service space, proper coverage, everything is considered. This is for a food courts where you can have units individually mounted so that again your oil, grease, anything does not go to your main duct. The cleaning happens right at the stage of generation of smoke. In some very rare cases, when the space is constrained, we also do scrubbers with multiple passes. So this is, if you remember my point of contact time. So here what will happen is, since you are making double pass, your cross-sectional velocity will be higher. But since you are having increasing the depth of the filter, your contact time of 0.1 second is achieved. So this obviously will increase the pressure drop. But in some cases where there is very critical limitation on space, we have even done 3 pass also. But 2 pass is definitely possible wherever required. Here the first stage will get choked very quickly. So that cleaning frequency will be very high. Second will be normal. Okay, then important points. Scrubber should be as close to the hoods as possible. Inverted comma, space permitting, because space is a very big challenge in all the kitchens. There is a misconception, many inquiries we see where the scrubber and fan are put together. Actually, scrubber should be as close to hood as possible and fan can be anywhere. There need not be a one system. Scrubber and fan did not be one HU. Ideally, it should be separate. Power to be interlocked with fan, that's very common. Removal, handling, washing should be easy. We have a possibility of BMS connection for monitoring. It gives indications for fault, it gives indication for cleaning required, and the system can be maintained very easily. Now these are some of the places how not to install. So in this case, the railing is right in front of the door. The door cannot be opened. Of course, we got it rectified, but this is a photo taken before. And the scrubber service will never happen. This is another installation, ceiling suspended, the door doesn't open, the filter cannot come out, the servicing will not happen. Same. Or many times we see some fire pipe, some cable, some duct running in front of the door. This door needs to open more than 90 degrees for easy removal of cell. These are some important points, similar, self-explanatory. Now we come to service very quickly. Basically, the sails can be removed and they need to be washed. The unit indicates when the servicing is required on the unit itself or on the BMs. You can see an example of a very dirty, abused sail, but one can really wash it and it becomes as new as possible, ready to use again. So this is what it is. I don't think there is time for question and answer, so I will conclude. Thanks.
Thank you so much, sir. I now request Mr. Virendra Borade, sir, to kindly felicitate Harshad Patil, sir. Yes, so next we have Copeland. From Copeland, we have Mr. Rahul Padhak. He is a product manager in Copeland and is responsible for product marketing and business development and has a total work experience of 15 plus years. So let's welcome him with a big round of applause.
Hello. Good evening, everyone. I'll just take you through the three portion of our Copeland presentation. One is the brief of our company, followed by the digital scroll technology that we are promoting, the process chiller, so some charts on digital scroll. And towards the end, we'll have some updates on the heat pumps, what we are doing as a company to help the heat pump industry. So these are the three sections of our today's presentation. All right. So in May, Blackstone Group has acquired majority stake of Copeland, and they have formed a standalone company called, Copeland. This is actually helping us to kind of give focused efforts on the product development for the HVAC and our industry. It is always a difference between being a conglomerate and being a standalone company. So this change will definitely help us to give more focus, more investment to, develop product for the HVAC and our industry. Since we became Copeland, we started, announcing the Copeland, the inauguration of the Copeland logo in key cities across India. So we inaugurated this new logo of Copeland. The blue color actually denotes the strength and the confidence of the company, and the delta, the algebraic symbol, which actually denotes the change. Okay, change to kind of create the value for our people, for our customers, as well as our planet. This is a quick update on the financial overview of Copeland. It's around $5.1 billion company. Around 80% of revenue comes from the repeat. So it actually gives the the customer loyalty experience as far as the transaction with the customers are concerned. Around $150 million installation, whether it's receipt compressor or the scroll compressors. Around 3,000 patents from the company. As far as the business is concerned, the EMEA, where India is part of, represent around 19% of the total revenue, and 50% plus revenue comes from the US. All right. So with this brief, quick update on the company, let's go to the second portion of today's discussion. Is on the two portions. One is the process chiller, and the second is the heat pump. Now, Copeland is there for a long time, more than 100 years in in HVAC and our industry. And you must have seen Copeland being present, whether it's a transport application, electric bus or Vande Bharat or any trains which you travel. We cool those trains with the Copeland scroll compressor technology. Likewise, we are present through ducted machines, through scroll chiller machines in the commercial applications. You take data centers. Data centers are cooled to precision ACs powered by Copeland scrolls. And the last two where we have a focused discussion today is on the process chiller, which is actually a very critical application for any industry. We'll have more discussion in upcoming chart. And the last one is the heat pump, which is actually, it's a growing technology, it's a new technology for India market. Many of the boilers are now getting replaced with the heat pump for the sanitary water heating. So we'll have more discussion in coming charts. All right. So, we'll start with the process chiller application. You take any industry, whether it's food processing, the plastic molding, laser machine, pharmaceuticals. The process chiller is a critical component of any industry because it governs the quality of the product it produces. You take an example of food processing, take an example of pharmaceuticals, laser machines. If something goes wrong as far as the the water outlet temperature of the process chiller, your quality of the product will differ. Okay, and the second one is, since this is a 24-hour application, the energy efficiency becomes very important, right? So when I spoke to many process chiller guys, particularly the end user market, they said these are the two critical components as far as this industry is concerned. One is the maintain the precise temperature, and second is the energy efficiency. So with that logic, what we did is we took one process chiller in our Karad engineering lab, And we tested this process chiller with a standard fixed speed compressor and replaced that with a digital scroll. Now, before I talk about this value story, I think many of us here know about the digital scroll. So that is the reason I skipped the chart, the basic chart on the digital scroll. But just to kind of ensure everybody is on the same page, digital scroll is actually the mechanical modulation technology, which actually varies the capacity of the compressor from 10% to 100%. And likewise, we also have an inverter or the variable speed compressor, which is electrical modulated technology. The capacity of the compressor is varied based on the frequency of the motor. So this is actually a basic difference between the variable speed and the digital scroll. So coming back to this chart, we replaced the fixed speed with the digital scroll, and we tested this process chiller with IS 16590, which is actually a comfort AC testing standard. Since process chiller didn't have a test standards, we took this 16590 as a base and tested this machine. So we got around 28% saving between the fixed speed and the digital scroll. But I always had a doubt, because lab always have a comfort, the controlled environment. So we thought of checking this value story with other OEMs, process chiller OEMs. So instead of 28%, as expected, we got around 10 to 15% saving of digital scroll versus fixed speed and a process chiller application, which is still a gain for any end user. So the second thought is, because I have seen process chiller industry has started moving to the variable speed from last 4 or 5 years to kind of address the energy efficiency, the precise temperature requirement. But the problem was the end user was not ready to pay the incremental cost for the inverter, right? And that is the reason we still find process chiller with the standard compressor. With this logic, what we did, we said, if market is not ready to pay for the variable speed or inverter compressor, how about introducing a digital scroll with a much lesser cost than the inverter compressor? So if you see this, the overall costing of a process chiller, the process chiller, say 5-ton process chiller with standard compressor, cost you around 1,30,000 rupees, which is a cost. The market price is somewhere around 2,30,000 rupees if you go and try to buy the 5-ton process chiller. Whereas the same chiller, if you want to buy with an inverter compressor, the price is around 3,30,000, almost 1 lakh rupees higher than the standard compressors. So what we did, we sat with the OEMs and tried to kind of see what costing comes out if I put a digital compressor instead of a standard compressor. So the costing is coming out to somewhere around 1,50,000. Only marginal difference of 1,30,000 to 1,50,000. So 20 to 22,000 higher than the standard compressor, whereas inverter was costing around 1,90,000, right? So which is actually a benefit for any process OEM, because he can still position this process chiller with the digital compressor at 2,60,000, almost 30,000 more than the standard compressor, instead of asking 1 lakh rupees additional from the end user. So that is actually helping the process chiller guys to kind of adopt these digital scroll compressors into their chillers. And most of the OEMs are under qualification stage, and you will see this industry slowly moving towards the digital scroll compressor instead of fixed speed. Now, even the ROI, if you see on the right hand side, ROI, if I put all the numbers, since I don't have a time, so I won't be able to go into the details of it. But the ROI which is coming out for digital scroll is around 12 to 13 months, where a variable speed would be around 20 to 24 months, right? This is the range of the digital scroll. It starts from 3 HP and goes up to 15 HP. Energy saving, better comfort, reliable, and the electromagnetic interference issue, there is no EMI issue over here, because this is a mechanical modulated compressors and not a electrical modulated. Right? One challenge we always faced, particularly while working with the tier 2 OEMs, because of their limited engineering capabilities, we always say, okay, we are good with the compressor, but how about the controller? So we tied up with a third party and developed a dedicated controller with HMI for this solution. So this controller is available with both TXV as well as the EXV, and even we have given 2 programs for the end users, because industry like, say, diamond cutting, they are more concerned about the preciseness and not the energy efficiency. So we have given 2 programs for precision temperature as well as the energy efficiency. So based on the requirement of the end customer, he can choose which program he wants to go for and run the process chiller. Right. So with this a short presentation on the process chiller, I'll switch my gear to the heat pumps. Now, from last 5-6 years, we have started kind of, transitioning ourselves from a compressor manufacturer company to a, solution providing companies. And then 2017 onward, we have started designing and building these heat pumps in Chaka near Pune. Now, I think most of us know, heat pump is a greener technology, and it's the answer to the boilers and the electrical heaters because of the COP. What it does is actually it extracts the heat from the atmosphere and pass it on to the water through different types of the heat exchanger, be it the shell and tube or tube and tube or the PHEs. So that's the job of any heat pump. Now, in the overall process, the main advantage of heat pump is the COP of the system, because it's around 3.5 to 4. So if you give a 1 kilowatt of heat input, you actually get 3.5 or 4 kilowatt of heat output. So that's the major difference between the conventional way of heating the water compared to heat pump, right? Now, so these are the range of heat pump that we design and manufacture in India, start from 3.5 and goes up to 72 kilowatt. Recently, we have also developed a 15 kilowatt high temperature heat pump, which actually gives 70 degrees Celsius water temperature. The rest of the heat pumps are up to designed for 55 degrees Celsius. So this is the heat pump that we have designed and manufactured. Is a 70 degrees Celsius water temperature, and basically this product development came from the input from many consultants from South, that the 4-star and 5-star property need this 70 degrees Celsius water to kind of maintain the hygiene of even the sanitary water heaters. They want to kind of prevent the bacterial growth even for the sanitary water. That's the reason we have developed this particular heat pump for the 5-star category hotels. There are a couple of uniqueness of the Copeland heat pump. One is the ZW compressors. This is a dedicated compressor that we have designed for heat pump, because the normal air conditioning compressors, if you see the if you want to maintain the 20 degrees Celsius inside when the outside is -7, the work done by the normal air conditioning compressor is lesser compared to work done by a compressor in heat pump. Because if you want to maintain the 50-55 degrees Celsius water temperature, your condensing temperature will go around water temperature is 50, then condensing temperature will go about 55 degrees. So work done by the heat pump compressor is much higher than the normal compressor. So you need a dedicated compressor which has a wider envelope so that it won't fail in the extreme conditions. In addition to that, one more feature is the Green Pro certified. So we have actually gone through all the process of IGBC Green Pro certification. We have gone through that process and we got the Green Pro certification also. So any IGBC green building project, this heat pump is certified. So all in all, I'll not go into the details of each and every advantage, but the main takeaways for Copeland heat pump: one is this is locally designed, locally manufactured for India climate condition. This is the Green Pro certified product. And the third one is it uses a dedicated ZW compressors for heat pump. So these are the three main advantage, I would say, compared to the normal heat pumps. These are some of the installation that we have done. Around 4,000 plus installation we have done so far, like Ramada, Mayfair, Google sites in Hyderabad, Bangalore we have done with our system integrators. So key takeaways, this is my last chart, is we are continuing to invest to develop sustainable and energy efficient solution for AC and heating industry. We'll have focused effort on the process chiller industry. We want to kind of move the process chiller industry from a standard compressor to a digital scroll compressor. So dedicated programs are being handled by our company. And of course, heat pump is a new segment, and we are quite sure that in next 5 years, most of the boilers in the hospital, the hotels will get transferred to the heat pump. And we are working with the key stakeholders in industry to kind of help them to transfer this technology from boilers to heat pump. So that's what I want to do. So we also have a stall outside this hall, so kindly visit this stall. Thank you.
Thank you so much, sir. I now request Mr. Deepak Wani, sir, to kindly felicitate Mr. Pathak, sir. So now I would like to call upon Mr. Nilesh Gaikwad, sir, for further proceedings.
Thank you, Roshni. Myself, Professor Nilesh Gaikwad. I am student chair of this current society here. Most of the industries, people here complain that they don't get skilled manpower. In order to bridge this gap, ISHRAE has taken a right initiative to disseminate knowledge and train students related to HVACR industry right at the institute. But in order to propagate this movement into the institute, the most important factor is the faculty advisor. I personally believe that faculty advisor is the backbone of all these activities. To recognize the efforts of all these faculty advisors, ISHRAE HU has taken a right step. This time they have sent a letter of appreciation to all such active faculty advisors. Whosoever chapters were installed before 5th of September, ISHRAE HU has sent a letter of appreciation to all of them. So we at ISHRAE Pune chapter thought that what would be a better occasion than ACR trend to recognize all these faculty advisors on the stage. So I'll call Roshni to take over the charge.
So the felicitation ceremony we'll now be having is not just a validation of our faculty advisors' achievements, but it is a reminder of their limitless potential and the incredible work they have done for us. So I would now like to call upon Mr. Nandkishore Kotkar sir and Anup Balani sir for the felicitation ceremony. First, we have Professor Shivari Maknikar from Z College of Engineering and Research. Congratulations, sir. Now we have Professor Ruturaj Kulkarni, sir, from SB Patil College of Architecture and Design. Thank you and congratulations, sir. And last we have Thank you, sir. And at last we have Professor Nilesh Gaikwad, sir, from Pimpri Chinchwad College of Engineering, Nigdi.
Thank you very much. Faculty advisor is just face of the activity. This award is dedicated to all the students of respective student chapter and the supporting faculty advisor team. Thank you. I have one more exciting news to share. This year, Record Hackathon competition was organized by ISHRAE HU. And I'm happy to tell you that one of the students from PCCO ISHRAE student chapter, along with his two colleagues from WIT Solapur, participated cleared their scrutiny round through zonal and national level, and they won the first prize of rupees 1 lakh at finals of Record Hathakar. So let's join hands together to felicitate Mr. Anil Katte. I request Kotkar sir to felicitate Mr. Anil Katte.
Thank you so much. Now I call upon Mr. ISHRAE sir at Aeon, partner at Aeon Consultants, postgraduate in thermal engineering with over 30 years of work experience. He is a seasoned consulting engineer who has designed over 4,000 projects. He specializes in high performance buildings and has been actively involved in leading design activities of electromechanical services for 11 net zero buildings, 2 net zero water townships, and over 100 platinum rated green projects in India. He is a presidential member of ISHRAE and first Indian to be elected as vice president and serves on the board at ISHRAE USA. So let's welcome him with a big round of applause.
Namaskar, everyone. It's good to be back in Pune. मुझे भी सुरेश साहब जब मैं आ रहा था यहाँ पे हिंदी चलेगा ना, हाँ, तो मज़ा नहीं आता इंग्लिश में तो अब, और हमारे जो प्रेसिडेंट इलेक्ट साहब हैं उनको एडवाइस है सर हिंदी में ही बात करने का था। तो जब मैं यहाँ पे आया तो सुरंगे साहब ने बोला कि इनका पुणे के साथ प्यार है, राइट सर, सवेरे आपने यही बोला था, और पुणे को इनसे प्यार है, इनको पुणे से प्यार है, इसलिए बार बार आते हैं ये। सर वो तो ठीक है, लेकिन मैं इतनी सारी टेक्निकल टॉक कहाँ से लेके आऊं? तो अब मेरे लिए तो सबसे बड़ा चैलेंज यही हो गया है कि पुणे बुलाता है, आना होता है, मना नहीं कर सकता, और फिर मैं सोचता हूँ मैं क्या करूँ, मैं जो काम कर रहा होता हूँ फिर इमीडिएटली उसको I put that in a formal way. कोई बात नहीं, प्रॉब्लम ओके, आ गया, ठीक है, थैंक यू। थैंक यू। सो देन आई स्टार्टेड थिंकिंग कि अच्छा बेस्ट पार्ट ये है पुणे का, सर आप आएंगे, मैंने कहा आऊंगा, वो कहाँ गए मेरे बोरडे साहब, वो हमेशा जब मेरी टॉक शुरू होती है बाहर चले जाते हैं, ये थर्ड टाइम है, और जैसी टॉक खत्म हुई, सर आपकी टॉक बहुत अच्छी थी, कोई उनको फोन कर दो। So coming back to this, so मैंने कहा सर आपने आना है, मैंने कहा ठीक है। मुझसे किसी ने पूछा बोलना क्या, किसी ने नहीं पूछा। एक दिन पहले सर आप किस चीज पे बोलेंगे, मैं बिजी था बहुत उस वक्त, किसी मीटिंग में था, मैं इस टॉपिक पे बोलूंगा। फिर जब मैं यहाँ आया मैंने कहा मैं इस पे तो बोल चुका हूँ, तो मैं अब क्या करूँ, तो देन आई क्विकली वर्क ऑन समथिंग न्यू, एंड एक जो बहुत, सागर यू आर बैक, ओके थैंक यू। सो देन आई वर्कड ऑन समथिंग न्यू बिकॉज ये टॉपिक बहुत क्लोज है मेरे हार्ट के, ऑन वाटर कंजर्वेशन। आप ही कहोगे कि एचवीएसी इंडस्ट्री के लिए मैं वाटर कंजर्वेशन पे क्यों बात कर रहा हूं, इसका क्या लेना देना, बट एक्चुअली एचवीएसी इंडस्ट्री इज द मेन डिफॉल्टर and someone who can actually save a lot of energy by conserving water. एक टर्म पूरे इंडस्ट्री में यूज होता है इंटरनेशनली जिसको कहते हैं एनर्जी वाटर नेक्सस। उसका मतलब ये है एनर्जी और वाटर की आपस में रिलेशनशिप क्या है, इसके ऊपर पूरे वर्ल्ड में आज में टॉक्स हो रही हैं, और डीकार्बनाइजेशन का ये वन ऑफ द मोस्ट इंपॉर्टेंट एजेंडा है। हम सब जानते हैं कि एनर्जी हम उसके बिना भी रह सकते हैं, मुश्किल से रहेंगे लेकिन रह सकते हैं, लेकिन पानी के बिना हम नहीं रह सकते। एनर्जी कहीं खत्म नहीं हो रही, लेकिन पानी की जो आज हाल है, देयर इज अ बिग चैलेंज आउट देयर। तो मैं उसके ऊपर आज मैंने सोचा मैं बात करते हैं, लेट्स टॉक अबाउट दैट। सबसे पहले पानी को समझ लेते हैं। आई हैव 55 मिनट्स हैव बीन गिवन, सो बलानी साहब मैं पूरे 55 मिनट ही लूंगा। ये मेरे को वहां से कस्में दे रहे थे कि आशीष आधा घंटा, मैं पूरे 55 मिनट ही बोलना है मैंने। Okay. So, coming back to this, on a serious note, so out of the total water volume जो पूरे वर्ल्ड में अवेलेबल है, 97% हमारे सी वाटर है, सॉल्ट वाटर, जो कि हमारे लिए ड्रिंकेबल उस फॉर्म में नहीं है। ओनली 3% इज फ्रेश वाटर, और उन 3% में से भी जो 70% है वो ग्लेशियर्स और आइस कैप्स में है। जो अवेलेबल है हमें सिर्फ 1% इज सरफेस वाटर, एंड बाकी जो बच गया 30% ऑफ दिस 3% इज व्हाट इज अवेलेबल एज ग्राउंड वाटर। जो पूरा आज हमारा देश चल रहा है वो इस सरफेस वाटर और ग्राउंड वाटर के ऊपर चल रहा है, और दिस इज द वाटर दैट वी हैव। अगर वर्ल्ड में वाटर यूज की बात करें, सबसे ज्यादा जो वाटर कंज्यूम करते हैं वो है डेवलप्ड कंट्रीज, वैसे ही जैसे सबसे ज्यादा एनर्जी कंज्यूम करते हैं। दिस गॉड की गिफ्ट है उनको कि उनको खूब सारी पानी भी मिला है। अगर आप नॉर्थ अमेरिका में चले जाएं, यूरोप में चले जाएं, कोई प्रॉब्लम नहीं है वाटर की, वहां पे काफी पानी है उनके पास। और वो जो प्रैक्टिसेस हैं वो सारी की सारी हमारे देश में भी आ रही हैं और डेवलपिंग वर्ल्ड में भी जा रही हैं। वाटर इंटेंसिटी कितनी हाई है मैं बताता हूं। आप एक चॉकलेट खाते हैं, एक चॉकलेट को बनाने के लिए 24,000 लीटर पानी लगता है, एक चॉकलेट को बनाने के लिए। इसी तरह से अगर आप एक कप कॉफी पीते हैं, उस कॉफी के लिए 140 लीटर पानी एक कप कॉफी में जाता है। ये वाटर का कंजम्पशन है, और इस तरह के और भी फैक्ट्स आपको यहां पे मिलेंगे। कुछ कंट्रीज जो हैं वो तो वाटर के इंपोर्ट पे डिपेंडेंट है, जैसे मिडिल ईस्ट सारा है, या फिर कुछ अफ्रीकन कंट्रीज भी पूरे वाटर इंपोर्ट्स पे डिपेंडेंट है। अगर आप इंडिया का देखें, कुछ फिगर्स हैं। आज की डेट में जितना पानी जितना हम हार्नेस कर पाते हैं और जितना हम कंज्यूम कर रहे हैं, उसमें एक मिसमैच आ गया है। आज की डेट में कंजम्पशन ज्यादा है और हार्नेसिंग कम है। I think we need to give first a round of applause to Mr. Borede. He is here not only because of he is here, but because of the work that he has done for Pune chapter. I think he deserves that. So thank you, Virendra, for joining us today. So as I was saying कि consumption ज़्यादा है, और जो हमारे harnessing है, जो पानी को जो हम कैप्चर कर रहे हैं, या फिर जितना हमारे पास ग्राउंड वाटर अवेलेबल है, जितना हम उसमें एब्जॉर्ब करा पाते हैं, उससे ज्यादा हमारा कंजम्पशन शुरू हो गया। सो वी आर नाउ अ डेफिसिट इन वाटर टू अ स्टेट, टू अ पॉइंट। जो आप ये देख रहे हैं, जो इंडिया का मैप है, ज्यादातर रेड एंड ऑरेंज में है। दैट मीन्स दीज आर ऑल वाटर डेफिसिट स्टेट्स, जहां पे एक्सट्रैक्शन ज्यादा है और रिचार्ज कम है। These are the major states which are facing problem. पूरे इंडिया में प्रॉब्लम है आज की डेट में. But these are the major states that's facing problem, and look at the major cities that are facing problem. All big cities are now running into a troubled zone. Best part ये है कि जिन cities में बहुत अच्छी रेनफॉल होती है, जिसमें कि बैंगलोर आता है, और बैंगलोर इंसिडेंटली आपने कई लोगों ने सुना होगा कि बैंगलोर इज द फर्स्ट डे जीरो सिटी ऑफ इंडिया। डे जीरो सिटी क्या है? जहां पे फ्रेश वाटर जो है प्रैक्टिकली खत्म होने को आ गया है। आप में से कितने लोग बैंगलोर गए हुए हैं? कितने घंटे म्युनिसिपल वाटर सप्लाई आती है? लेस देन 4 hours a day is the municipal water supply. ज्यादातर बैंगलोर आज टैंकर्स के ऊपर चलता है। जब मैं बैंगलोर में प्रोजेक्ट डिजाइन करता हूं तो सबसे पहले टैंकर प्रोविजन के ऊपर बात की जाती है कि कैसे टैंकर से पानी आएगा वहां पे, जबकि बैंगलोर गेट्स अ लॉट ऑफ रेन. सो दिस इज द आयरॉनिकल सिचुएशन दैट वी गेट सो मच ऑफ वाटर बट उनका कंजम्पशन नहीं है, कंजम्पशन ज्यादा है. What will this scarcity bring to us? Environmental risk. Of course, as we are melting down the glaciers, there's a big problem there. Social risk, because जब पानी खत्म होगा तो एक मूवमेंट शुरू हो जाएगा मैन पावर का, लोगों का. Incidentally, there is a very famous book which is there. I'll give you the name of the author also. If you read that book, it says the biggest migration which is going to take place due to climate change is going to be in India. Biggest migration in the world on account of climate change is going to happen in India. Why? Because India is dependent on snow-fed rivers. जब वो स्नो ही नहीं होगी तो स्नो-फेड रिवर कहां से होगी? एंड एज अ रिजल्ट पॉपुलेशन विल मूव करके कहां जाएंगे, किस पार्ट ऑफ द वर्ल्ड में जाएंगे, वो एक अलग स्टोरी है. द बिगेस्ट माइग्रेशन इज प्रेडिक्टेड इन इंडिया एंड पाकिस्तान. So if you read that book, is scary what we are going to go to. That is the social risk. And finally the economic risk, पानी के लिए चार्ज करना तो is still a big problem. There is no such thing as that. हमने आज तक हमेशा एनर्जी को एक्सपेंसिव माना है. मैंने जितनी भी टॉक देने आता हूं, जितनी भी कॉन्फ्रेंस में जाता हूं, we talk of energy conservation. We never talk of water because water is taken as granted and energy is what we consider as expensive. Things like this are very common. आप भी किसी भी part of India में चले जाएं, this is what you will see. This is going to become worse. आज की डेट में India is the most populous country. We are 1.42 billion people and we are not stopping. The prediction is that we are going to stabilize at 1.7 billion. 1.7 billion के बाद हम वापस नीचे आना शुरू होंगे and we'll come down by end of the century to 1 billion. But till that point, we have a big challenge that is there. उसके अलावा buildings बन रही हैं, and buildings is what I want to show to you where the problem is in terms of water. और ये building बनती ही जाएंगी. We have, India is the largest contributor to the construction industry in the world at this point of time. We are the largest, we are number 1 in building construction right now. This is the graph right here. And we'll continue to be number 1 because China has slowed down. China has a big real estate problem. All of you must be reading about it. आपने सबने पढ़ा होगा. सारा जो अब कंस्ट्रक्शन का जो सारा फोकस है for next 30 years वो इंडिया में ही होगा और यही बिल्डिंग्स बनेगी. और जब ये बिल्डिंग्स बनेंगी, इनका जो इम्पैक्ट है आप देख ही रहे हैं, बिकॉज सारी पॉपुलेशन जो है वो कॉन्सेंट्रेट होती चली जा रही है in a smaller part. पुणे आप यही देख लीजिए जहां पे इस वक्त हम जिस हाईवे के अलॉन्ग है. आज से 10 साल पहले जब हाईवे 20 साल पहले जो हाईवे बना था, यहां कुछ नहीं होता था. आज this is one of the most crowded place in Pune at this point of time. Right? This is the impact which the buildings are going to have because a lot of people get concentrated in a small area और वहां पे पानी का एक इशू बन जाता है. Climate change is a reality. जो इस बार इंडिया के फ्लड्स थे, लास्ट ईयर पाकिस्तान के फ्लड्स थे. Why I'm taking India and Pakistan is because हम सब एक ही बेल्ट में हैं. जो हम फेस कर रहे हैं, that is a reality. This is what we are seeing at this point of time. एक तरफ तो हम इसकी बात करते हैं, दूसरी तरफ हम डीकार्बनाइजेशन की बात करें. और जब भी डीकार्बनाइजेशन की बात करते हैं, हम आके यहाँ पे बात करते हैं एनर्जी कंजर्वेशन, जैसे कि उसको करने से हमारी प्रॉब्लम सारी सॉल्व हो जाएंगी. Every time we talk, right? Energy is what we talk. So can we have those people please just all right. So let's come back here. So every time we talk about that is कि जैसे energy conservation is the सारा solution वहीं बैठा हुआ है. Decarbonization is not only about energy solution. Decarbonization is a much bigger subject. आज की डेट में decarbonization is real. 88% ऑफ द एमिशन जो वर्ल्ड में प्रोड्यूस होता है, जो भी उसकी कंट्रीज उसके लिए रीजन है, उन सारी कंट्रीज ने कमिटमेंट दे दिया है डीकार्बनाइजेशन का, एंड इंडिया इज वन ऑफ देम. वी आर द थर्ड लार्जेस्ट कार्बन एमिटर इन द वर्ल्ड. एंड ऑफ कोर्स कहां सबसे ज्यादा मैक्सिमम कार्बन निकलता है? हमारे कंस्ट्रक्शन इंडस्ट्री से होता है. 40% of the global carbon emissions comes out of our construction industry only. Now come the fun. A lot of you have seen this slide. I use this slide a lot. Carbon. Where is this used? Carbon emission take place during construction, during operation and demolition. During construction, पानी की डिमांड बहुत हाई है. बिना वाटर के कंस्ट्रक्शन नहीं हो सकता. During operation is right here. You see this green? This is water. This is leading to carbon emissions. और हम बात क्या करते हैं? सिर्फ एनर्जी, एनर्जी, एनर्जी. हम वाटर के बारे में बात ही नहीं करते. Throughout the life of the building, जब से बिल्डिंग स्टार्ट होती है, जब बिल्डिंग खत्म होती है, all along the operational carbon that is being emitted, उसका water is a major contributor. We are talking, आप में से किसने स्कोप 1, स्कोप 2, स्कोप 3 एमिशन सुना है? Very few, right? I think जो आज बलानी साहब ने सवेरे बोला था कि एक बेसिक अभी शाम को ही बोला था, एक बेसिक समझना जरूरी है व्हाट इज डीकार्बनाइजेशन, बिकॉज ये रियलिटी है. और वन ऑफ द इम्पॉर्टेंट पार्ट ऑफ दिस इज, ये सारी चीजें हम सबके लिए इंपॉर्टेंट होने जा रही है. आई एम नॉट गोइंग टू कवर दिस टॉपिक राइट नाउ. सॉल्यूशन क्या है पूरे डीकार्बनाइजेशन का? वी आर टॉकिंग ऑफ नेट जीरो एनर्जी, नेट जीरो वाटर, नेट जीरो वेस्ट बिल्डिंग. और आज तक पूरी एचवीएसी इंडस्ट्री जो कॉन्सेंट्रेट करती है, ये यहां पे रुके हुए हैं. दिस इज वेयर वी स्टॉप. हम में से कोई इसके बारे में बात ही नहीं कर रहा. ये हमारी प्रॉब्लम ही नहीं है. बट दिस इज द बिगेस्ट प्रॉब्लम. आपकी प्रॉब्लम है, मेरी प्रॉब्लम है, पूरे सबकी प्रॉब्लम है, बिकॉज ये पानी मैंने आपको दिखाया था खत्म हो रहा है. ग्राउंड वाटर एक्सट्रैक्शन इज फास्टर देन द रिचार्ज टेकिंग प्लेस, एंड वी डोंट हैव मच ऑफ ग्राउंड वाटर लेफ्ट. अगले, it is said by 2030 we are going to come into a crisis state in our country अगर if we continue like this. ये ग्रीन बिल्डिंग नॉर्म्स हैं. आपने रेटिंग सिस्टम्स देखे होंगे, यूएसजीबीसी, आईजीबीसी, ग्रेहा. ये सारे वाटर कंजर्वेशन पे वो करते हैं. अमेरिकन सिस्टम इंसिडेंटली 10% ऑफ इट्स पॉइंट आर फॉर वाटर एफिशिएंसी. अगर मैं ये इंडियन सिस्टम पे जाऊं, इंडियन में 20% of its point are on water efficiency. और मैं गृह में जाऊं तो another 16% or something, yeah, 16% is on water efficiency. Least importance is given is in international rating system because वहां पे पानी की उतनी प्रॉब्लम नहीं है जितनी हमारे यहाँ है. Right? You can see the trend. Let's understand हो क्या रहा है पानी इसमें. Now, all of you must be thinking HVAC industry क्या कर रही है, and I'm going to demystify that for going forward. हमारे rating systems, हमारा IGBC rating system, गृह rating system, lead rating system, health and well-being rating system, all of them talk about water. सब में पानी मौजूद है. Green rating systems जितने होते हैं, वो कहते हैं कितना पानी यूज कर रहे हो, कैसे उसको कम कर सकते हो कंजम्पशन. तो हेल्थ एंड वेलबींग रेटिंग सिस्टम है, जो वेल और हेल्थ एंड वेलबींग है, दे टॉक अबाउट क्वालिटी ऑफ वाटर. सो एक रेटिंग सिस्टम फोकस करता है क्वांटिटी ऑफ वाटर, दूसरा करता है क्वालिटी ऑफ वाटर पे. बट वाटर इज एन इंटीग्रेटेड पार्ट ऑफ ऑल रेटिंग सिस्टम्स. ऑल ऑफ दीज, चाहे वो हमारा रेटिंग सिस्टम्स हो, चाहे हमारा नेशनल बिल्डिंग कोड विच गवर्न्स द वाटर एज अ मेन इशू, लेट जो भी वर्जन्स आए हैं ओवर अ पीरियड ऑफ टाइम, ऑल ऑफ देम हैव कॉन्सेंट्रेटेड ऑन वाटर. नाउ लेट्स अंडरस्टैंड कि हमारे ग्रीन रेटिंग सिस्टम्स और कोड्स में क्या डिफरेंस है. ये जरूरी इसलिए बिकॉज दिस फॉर्म्स द बेसिस. हमारा नेशनल बिल्डिंग कोड जो हम अपनी लाइफ साइकिल से देख रहे हैं, 2005 का एनबीसी था. 2005 के बाद 2016 का एनबीसी आया, जो अभी चल रहा है इस वक्त. और अब गवर्नमेंट ऑफ इंडिया ने 2023 में नए एनबीसी के लिए कमिटी फॉर्म की है, जिसकी की HVAC सेक्शन की मीटिंग जो है वो मंडे को किक ऑफ मीटिंग है एट 10 o'clock in the morning. If you see the 2005 और 2016 का जो नेशनल बिल्डिंग कोड है, there is no change in the water consumption pattern. वो कहते हैं कि 45 लीटर पर पर्सन पर डे लगेगा, वाटर कंजम्पशन होगा, चाहे वो ऑफिस की बिल्डिंग 2005 में बन रही थी या 2016 में बन रही थी. दैट मीन्स कोई भी स्ट्रिंजेंसी वाटर के ऊपर नहीं आई है इन लास्ट 20 years ऑफ द बिल्डिंग डेवलपमेंट. पानी निग्लेक्टेड है. दिस इज व्हाट आई एम ट्राइंग टू से. निग्लेक्टेड है आज की डेट में. ओनली रिवीजन टेक प्लेस बिटवीन 2005 और 2016 में था कि अगर 45 लीटर पर पर्सन पर डे आपका वाटर कंजम्पशन अगर आपका होता है ऑफिस बिल्डिंग में, तो उसको फ्लशिंग और नॉन फ्लशिंग वाटर में डिवाइड कर दिया गया. दैट्स ऑल. उसी का ब्रेकअप दे दिया गया, उसके अलावा कुछ नहीं हुआ. इफ यू गो टू द ग्रीन बिल्डिंग नॉर्म्स आर मोर स्ट्रिंजेंट. आज की डेट में सारा वाटर एफिशिएंसी जो ड्राइव कर रहा है इज नॉट बीइंग ड्रिवन बाय अ कोड, नेशनल बिल्डिंग कोड, जो कि पूरे इंडिया में फॉलो होता है, मैंडेटरी है. इट इज बीइंग ड्रिवन बाय द ग्रीन बिल्डिंग रेटिंग सिस्टम्स. और जब आप ग्रीन रेटिंग सिस्टम पे आप डिजाइन करते हैं अपनी बिल्डिंग, यू आर नॉर्मली डूइंग 20 to 50% बेटर देन व्हाट द NBC is specifying. Now why I'm saying this is because हर कोई ग्रीन बिल्डिंग नहीं बनाता. हम सब जाके प्रोविजन करते हैं, अपनी बिल्डिंग डिजाइन करते हैं बेस्ड ऑन द नेशनल बिल्डिंग कोड ऑफ इंडिया. और नेशनल बिल्डिंग कोड ऑफ इंडिया हैज नॉट चेंज्ड इन लास्ट 20 years टाइम. इसी तरह से रेन वाटर हार्वेस्टिंग इज नॉट एडिक्वेटली कवर्ड इन नेशनल बिल्डिंग कोड. Similarly, I will not get into the details. Similarly, water heating is not covered in the National Building Code adequately at this point of time. Similarly, even landscape is not properly covered. Landscape में जो पानी use हो रहा है is not covered there. Metering तो completely forgotten है, water metering. And let me come to the real issue what we are talking about. अब आज की डेट में जो सबसे बड़े इशू हमारे हैं वाटर को लेके, nobody understands plumbing is a neglected field. By the way, plumbing करता कौन है? World over plumbing कौन करता है? Plumber, very good. Design कौन करता है? Civil engineer. Are you agree with that? You are completely wrong. HVAC engineers design the plumbing systems world over. पूरे world में plumbing comes under mechanical and HVAC also comes under mechanical. It's the HVAC engineers who are also doing plumbing designs everywhere in the world. Plumbing is a neglected चीज. अगर हम सबसे कहते हैं ना, अपने बच्चों से कहते हैं आप इंजीनियर बनो, गलती से अगर हमारी इंडस्ट्री में आ जाओ तो HVAC इंडस्ट्री में आ जाओ, प्लम्बिंग में कोई नहीं भेजना चाहता हम में से. Right? Plumbing is neglected. There is no such thing as rainwater management. There is no such thing as changing weather pattern जो आज की डेट में हो रहे हैं. And there is nobody understands the water energy, water nexus. ये reality है आज की हमारे उसमें. Now go forward. We talk of integrated design. Integrated design. Integrated design में सबसे बड़ी चीज है between the energy water nexus, wellness of the people, carbon neutrality. All of that is part of sustainability, and water is an integrated part there. मैं आपको एक बहुत इंटरेस्टिंग स्टैटिस्टिक्स देता हूँ. वी वर डिजाइनिंग एयरपोर्ट, दिल्ली एयरपोर्ट का जो सेकंड जेवर वाला रहा है, वी वर डूइंग द डिजाइन. जब वो डिजाइन में शुरू किया तो सबसे पहली चीज हुई कि पानी का स्टोरेज कितना किया जाए, पानी का कंजम्पशन कितना होता है एक एयरपोर्ट में. तो मैं नेशनल बिल्डिंग कोड खोला तो उसके अंदर लिखा हुआ था 70 लीटर पर पर्सन पर डे. 70 लीटर पर पर्सन पर डे फॉर अ एयरपोर्ट डिजाइन. वहां पे रिप्रेजेंटेटिव्स थे दिल्ली एयरपोर्ट के, बैंगलोर एयरपोर्ट के, मुंबई एयरपोर्ट के. दे हैव बीन मीटरिंग द वाटर कंजम्पशन. द रियल वाटर कंजम्पशन वाज 14 लीटर्स पर पर्सन पर डे. अब क्या होगा, अब 70 लीटर पर पर्सन पर डे से एक दिन में सपोज मेरे 1 लाख लोग मेरे एयरपोर्ट से निकलते हैं. अब आप वाटर की स्टोरेज करेंगे. अब आप 70 लीटर पर पर्सन पर डे के हिसाब से स्टोरेज डिजाइन करेंगे. ह्यूज वाटर टैंक्स, ह्यूज पाइपिंग नेटवर्क, ये पूरा आप क्रिएट कर लेंगे. and then we start designing this. So look at the mismatch that is there. Today, जो हमारा नेशनल बिल्डिंग कोड है विज़ जो रियल डिजाइन है, there is a water difference of nearly, as I said earlier, 20% to 50% that needs to be fixed. A lot of water conservation strategies that need to be fixed. Now let's come to our part of it. HVAC engineers ने क्या करना है? I'm going to show you one एक project है ये शिमला में. Now शिमला incidentally कहाँ पे है? हिमालयस में. वहां पे पानी की कोई प्रॉब्लम नहीं है, वहीं तो कोई इशू ही नहीं होना चाहिए पानी का, राइट? हाउ मेनी ऑफ एग्री विद दैट? कोई इशू नहीं है? है? क्या है? इंसिडेंटली इन समर्स, जब भी गर्मियों की छुट्टियां होती हैं, शिमला में इतने लोग जाते हैं कि वहां पे पानी खत्म हो जाता है और न्यूज़पेपर आर्टिकल्स आते हैं, कभी भी गर्मी की छुट्टी में खोल के देख लें, जिसपे होता है कि साहब पानी खत्म हो गया शिमला के अंदर, प्लीज यहां पर नहाइए मत आप. अगर आपको नहाना है तो नीचे चंडीगढ़ चले जाइए, वहां नहा लीजिएगा, लेकिन यहां मत नहाइए. बिग 5-star होटल्स टर्न द पीपल अवे. पानी नहीं होता. इन अ प्लेस लाइक शिमला इन हिमालयस पानी खत्म. दिस इज द प्रॉब्लम हियर. अब ये एक टाउनशिप बन रही है, इन्होंने कहा था मैं बड़ी लग्जरी टाउनशिप है, यू कैन सी इन दैट. हमारी टोटल डिमांड इसकी 65,000 लीटर, 65,000 लीटर्स पर डे. मेरे को फ्रेश वाटर चाहिए यहाँ पे, फ्रेश वाटर रोज. और सब जो शिमला में घर लेते हैं, सेकंड होम होता है, हम लोग सब जाते हैं वहीं पे अपना छुट्टी मनाने के लिए, और मुझे वहां बोला जाए कि पानी खत्म हो गया, जाके नहा के आप चंडीगढ़ में आइए, 3 घंटा दूर है, और रहिए यहाँ पे. दैट इज नॉट गोइंग टू वर्क. क्या सिंपल सोल्यूशन है? लुक एट द रेनफॉल पैटर्न. ये जनवरी से लेके दिसंबर तक का रेनफॉल पैटर्न है. दिस शोज यू नंबर ऑफ रेनी डेज एवरी मंथ. इंटरेस्टिंगली एवरी मंथ इट रेन्स देयर. हर महीने वहां पे 2 दिन पानी जरूर होता है, और इससे ज्यादा ही होता है. हिल्स में जैसे ही पानी आपका एम्बिएंट टेम्परेचर 30 डिग्री के ऊपर चला जाता है, इमीडिएटली वहां पर रेनफॉल होने लगती है. ये एक टिपिकल पैटर्न है वहां पे. Look at it, there is a rainfall every month happening, and that place is water starved. What we did was very simple. जितना भी रूफ का पानी था हमने उसको कलेक्ट किया. रूफ का पानी इज अ क्लीन वाटर, उसको कलेक्ट किया, और जितना नॉन रूफ पानी था वो कलेक्ट किया. टोटल रूफ का पानी जो था अबाउट 10 लाख लीटर का स्टोरेज वो बनाया, एंड नॉन रूफ का जो रूफ से पानी आ रहा था 10 लाख लीटर का स्टोरेज वो बनाया, और जितना कि जमीन पे गिर रहा था 20 लाख लीटर का स्टोरेज उसका बनाया. टोटल 30 लाख लीटर पानी इकट्ठा किया. 30 लाख लीटर्स. 30 लाख लीटर्स बनाने में अगर मैं कहता हूं 20 रुपए लीटर लगता है, वी आर टॉकिंग ऑफ 6 करोड़ रुपए. एम आई राइट? 6 करोड़ रुपए. 6 करोड़ रुपए में द होल टाउनशिप is now having ample water, more water than what it can consume. You can see here, we have enough water to last us throughout the year. There is no problem with water shortage at all. All it requires is water management to be done here. This is the network that was created. ये छोटे छोटे टैंक जो आप देख रहे हैं, they all collecting the roof water from the villas. ये सारा पानी एक सेंट्रल स्टोरेज में आता है, वहां पे ट्रीट होता है, और उसके बाद ये वापस सप्लाई कर दिया जाता है. इसी तरह से दिस इज अनदर प्रोजेक्ट दैट वाज बीइंग डन इन क्लोज टू मुंबई. वेयर डू यू गो फॉर हॉलिडेज इन मुंबई? नॉट लोनावला यार. वेट. गेटवे ऑफ इंडिया से फेरी लेके कहां जाते हो? Alibag. So this is a project in Alibag. Thank you for it. Same thing done there, Alibag, okay? Why I'm saying is because this is very closer to this place. Sewage treatment plant, आज सबको पता है STP क्या होता है, रिसाइकल करता है वाटर. तो STP में कोई प्रॉब्लम नहीं है, हमारा पानी वहीं का वहीं यूज हो जाता है. There is no fresh water. टोटल मेरे को 7 करोड़ 18 लाख लीटर चाहिए पानी वहां पे जो मेरी की डिमांड है साल भर की 7 करोड़ 18 लाख, ये टाउनशिप वहां पे बन रही है, 7 करोड़ 18 लाख लीटर मेरे को साल का चाहिए। जो मेरे को रेन वाटर कलेक्शन टैंक से मिल रहा है 1 करोड़ 70 लाख लीटर मिल रहा है। बाकी 5 करोड़ 5.5 करोड़ लीटर वी आर एक्चुअली मेकिंग वाटर पॉन्ड्स देयर, पॉन्ड्स बना रहे हैं, वहां पे उसको यूज करने जा रहे हैं। ये सेम चीज, ये चेन्नई का वाटर रेट, आपको चेन्नई से अभी जयंती जी चली गई, आपने चेन्नई के बारे में सुना है कि दैट दे रैन आउट ऑफ वाटर कंप्लीटली एंड देन दे रैन अ प्रोग्राम ऑफ रेन वाटर हार्वेस्टिंग। आज उन्होंने प्रॉब्लम सॉल्व कर दी है उसकी। दिस इज द वेदर पैटर्न, नंबर ऑफ रेनी डेज इन चेन्नई विच टेक्स प्लेस। क्या प्रॉब्लम है? देयर इज इनफ रेन विच कम्स टू अस। दिस इज, आई लीव दिस हियर, दिस इज फॉर बैंगलोर। क्या प्रॉब्लम है? हर महीने तो पानी बरसता है। What is the issue? There is no issue anywhere. ये मुंबई का है, ठीक है, मुंबई में we have a problem 5 months 6 months से ये पानी नहीं बरसता, but 4 months to 5 months पानी बहुत बरसता है। इन सारा जो reservoirs बने हुए हैं, that is what runs the Mumbai. There is no issue with Mumbai. There is ample water that we get there. It's about the water management where the problem is. Now, what can we do vis-a-vis as an HVAC engineer? What we can do? We always talk of energy conservation. Energy conservation में अगर मेरे पास एक water cooled chiller है, और एक water cooled system है, air cooled system है, कौन उसमें से energy कम consume करेगा? Simple question. मैं रणनीति साहब से बड़ा complicated question नहीं पूछ रहा, बड़ा simple question पूछ रहा हूँ कि पानी energy का consumption water cooled system में कम होगा या air cooled system में कम होगा? Right, sir? Water cooled. Generally, most part of the India will say water cooled only. Ram, will you agree with that? Not always. Because when we did this NBC business, choti buildings, mein, we had that challenge. Okay, fair enough. But generally, the water cooled systems will show you a lower energy consumption in most part of the world, and especially in the larger, most part of India, and larger buildings. This is a building that we took as a case study. ये छोटी बिल्डिंग है. This is what we took as a 1 lakh square feet building. बहुत छोटी बिल्डिंग. और जनरली छोटी बिल्डिंग्स में क्या लगता है, हमारा चिलर नहीं लगाया करते, उसके अंदर हम लगाते हैं we put something like maybe a split unit, और उससे हम काम कर लेते हैं. There is no such thing as a double glazing. There is no such thing as anything be done. Typically इस बिल्डिंग में we had an air conditioning load of there's nothing written here. चलिए छोड़ देते हैं. We had an air conditioning load. We had an energy consumption which was happening on, here it is. We had an energy consumption 2,500 megawatt hours per year. There was no water being consumed by the HVAC system. We had water being consumed by landscape, flushing and domestic. So हमारा 27,500 kiloliter annual water consumption इस building का था. Small, so instead of using split units, what was done was, we started looking at either a VRF or a air-cooled system, and we also looked at a water-cooled system to be done. We started doing the comparison of it. The energy consumption in this case, what energy model showed, we could bring it down. हमारा energy consumption in a जो अभी हम चल रही building वो ये था. अगर मैं VRF या air-cooled system करूँ यहाँ था, और water-cooled system करूँ तो we had a saving in energy, but our water consumption went up because cooling tower makeup के लिए मुझे पानी चाहिए था. So this is what, then we installed a STP there in a choti si building. It was a small building, we installed an STP, and then what we found was very interesting was right here. Yeah. मुझे STP से treated water 22,000 kiloliter per year मिल रहा था, और मेरी जो पानी का consumption आ रहा था, total जो water consumption आ रहा था, बस 30,000 kiloliter का पानी का consumption आ रहा था, और वो पानी use हो रहा था मेरा cooling tower makeup, landscape और flushing पे. Now, there was an X air conditioning load. We had an air conditioning load. We had a power consumption, and we had a water. Now, these are three things that we are running there. We started optimizing the building design. That is, if you can see the cooling load there. That is the cooling load up there. We started optimizing the air conditioning design. We started bringing the cooling load down by doing better insulation, by doing what we call a insulated wall, insulated roof, double glazing, efficient lighting, LPDs, very low LPDs, heat recovery, all of that fundamental we started doing, and suddenly we found कि cooling load जैसे गिरता गया, मेरा जो cooling tower का water consumption था वो भी कम होता चला गया, and at some point of time we जितना पानी मेरा STP से निकल रहा था उतना ही पानी मेरे को total चाहिए था. So there was an equilibrium we reached. We brought the energy consumption down, and we also arrived at an equilibrium with the water consumption. So there was a relationship that was coming out. As we were bringing the energy consumption down, we were also able to equalize on the water that was being produced by the STP. फिर हमने उसको कहा कि सब इसको और efficient बनाते हैं. We reduce the water consumption even further. We use what we call a fixture जिसमें कि aerator लगता है, और बहुत हमने efficient water fixtures use किए, and जैसे से उसको use करते गए मेरा STP से जो पानी produce हो रहा था वो और कम हो गया, वो only 19,000 kiloliter per year हो गया, और जबकि मेरा consumption हो रहा था 22,000 kiloliter per year का. What we did was we even made the air conditioning system even more tighter. We introduced something called free cooling there. We introduced a concept of even tightened more envelope. We brought in some daylight sensors, brought some daylight into the system, and suddenly we found after doing all of that, we again stabilized between the water that was being consumed by STP and vis-a-vis the water that we were using for our air conditioning system. So we brought in the end, we brought the water consumption down from what was 30,000 kiloliters per year down to 19,000 kiloliters per year. We also brought the cooling load down from what was earlier down to 300 tons. Now that is where the decarbonization comes into the picture. You brought your operating cost down and brought your water consumption down. We brought an equilibrium between the two systems, and this is what an integrated design will be leading you in future. This is the EPI of the building that came crashing down, poorly designed. We are not talking of a large corporate making a building. We are talking about an MSME making a building. जो conventional building बनती हैं, उनका energy consumption vis-a-vis उन buildings में क्या किया जा सकता है to arrive at a lower energy bill and also bring down your water consumption there. Then we made it net zero water building. जितना भी मेरा पानी, ये मेरा पानी का consumption था. This was my total water consumption of the year. This is what I was able to get from the sewage treatment plant. Rest of the water we started storing there. And when we store that water, we reach what we call a net zero water status. Another project that we had the same challenge, we had a 190,000 liters of water requirement per day. The 190,000 liter after STP, मेरा सारा पानी जो था flushing और cooling tower में जा रहा था. There was nothing available, and I used a water cooled chiller. There was nothing available for me to use for landscape purposes. So landscape वाले ने कहा साहब मेरे लिए पानी कहाँ से आएगा इसके लिए? क्योंकि जब आप sewage treatment का पानी जो होता है, आप normally उसको flushing में use करते हैं, आप उसको landscape में use करते हैं, और आप cooling tower में use करते हैं. This is what the green building norms require you to do. There was nothing available for irrigation water here. Now एक तरीका देखने का, मैं HVAC engineer हूँ, मेरा काम हो गया, मैंने कूलिंग टावर में पानी यूज कर लिया और आई एम डन विद इट. मेरा काम पूरा हो गया. इसको मिले ना मिले, व्हाट ही कैन डू इज, वो चाहे बोरवेल लगाए या जो करे, जैसे भी अपना काम कर ले. दूसरा तरीका है देखने का, मैं फटाफट एयर कूल्ड चिलर लगा लूं, इसको जीरो बना दूं, और इस सारा जो 1 लाख लीटर पानी जो पर डे है, मैं इसको यहाँ पे इरिगेशन देना शुरू कर दूं. दिस इज हाउ करंटली द डिजाइन्स आर हैपनिंग. प्लम्बिंग इंजीनियर अपना डिजाइन करता है, HVAC अपना डिजाइन करता है, इलेक्ट्रिकल अपना डिजाइन करता है. We don't talk about integration between the three systems. What I was showing you पहले जो मैंने आपको एग्जांपल दिखाया था, how there is energy water nexus. जब आप कूलिंग लोड अपना कम करते हैं तो आप पानी का कंजम्पशन भी कम करते चले जाते हैं बिल्डिंग में, बिकॉज आपकी मेकअप वाटर रिक्वायरमेंट कूलिंग टावर की वो भी कम हो रही है. एंड वो कौन है जो उसका बैलेंस बनाएगा बिटवीन द वाटर कंजम्पशन and electrical consumption and air conditioning load? Who's that person who's going to do that? There is nobody in our industry who's doing this at this point of time. And that is where the biggest challenge is. Look at it here. Conventional, straight काम करते हैं, air cooled chiller लगाते हैं, पानी नहीं है, पानी नहीं. This is what happens in Bangalore today. पानी नहीं है, पानी नहीं है. This is what happens in Pune today. पानी नहीं है, air cooled system लगा दो. Right? When we go for air cooled systems, we are talking of higher energy consumption. We are also talking about water being used or misused or being thrown, recycled water being thrown into the stormwater network. Here it is, a hybrid chiller. We had put something what we call a combination of air-cooled and water-cooled chiller. Here it is. 53,000 liters is now going for here. 70,000 liters is being given to irrigation. Somebody needs to balance the system. आज हम सब सिर्फ अपने डिजाइन में बिजी हैं. We are not talking about building as a whole. And I'll show you bigger examples now. This is a township in Pune. मैं अभी नेम नहीं कर सकता इसको. In Pune, 160 acre township. You know what is the requirement of water? मैं यहां पे आ जाता हूं. This township is going to require, और यहां से ज्यादा दूर नहीं है, this township is going to require 50 lakh liter per day as a fresh water चाहिए इसको. 50 lakh liters per day fresh water. कहां से आएगा? Where does Pune gets its water from? Right? कितना पानी निकालोगे? इस टाउनशिप के रिक्वायरमेंट है 50 लाख लीटर पर डे. वो पानी आपका डोमेस्टिक यूज में यूज होगा, उसके बाद सुवेज ट्रीटमेंट प्लांट लगेगा, एसटीपी के बाद मैंडेटरी है उसको फ्लशिंग में डालना. मैं 30 लाख लीटर फ्लशिंग में डालूंगा. उसके बाद भी मेरा 27 लाख लीटर पर डे पानी निकल के आ रहा है. सुवेज ट्रीटमेंट प्लांट से एक्सेसिव निकल के आ रहा है. और ये पानी कहां जाएगा? स्टॉर्म वाटर नेटवर्क में. Am I right? ये प्लम्बिंग इंजीनियर का डिजाइन है. Who is going to do that water balance? वो पानी 27 लाख लीटर आप सिर्फ स्टॉर्म वाटर ड्रेन में डाल देंगे और 50 लाख लीटर आप रोज फ्रेश वाटर कंज्यूम करेंगे, तो नेट जीरो वाटर कैसे बनेगा? ये सी वेरी सिंपल. सबसे पहले ये जो सारी कैलकुलेशन है एनबीसी पे बेस्ड है. मैंने आपको शुरू में दिखाया एनबीसी के फिगर्स और आज की फिगर्स में एटलीस्ट 20% ज्यादा एफिशिएंसी है. सो मैंने स्ट्रेट अवे 20% कम कर दिया ऊपर फ्रेश वाटर डिमांड. 50 लाख लीटर से 40 लाख लीटर रह गया. क्यों? मैंने एरेटर यूज कर लिए, मैंने अच्छे फिक्सचर यूज कर लिए, लो फ्लो फिक्सचर यूज कर लिए. 40 लाख लीटर रह गया. उसके बावजूद भी जो एक्सेस वाटर था 20 लाख लीटर अभी भी जा रहा है. वो 27 लाख लीटर से 20 लाख लीटर रह गया, लेकिन 20 लाख लीटर तो अभी भी है. फिर मैंने बहुत सिंपल उसमें किया. आई सेड यहां पे टोटल इस टाउनशिप में कमर्शियल भी है, रेजिडेंशियल भी है. 4 लाख टोटल हमारा. वी हैव समथिंग लाइक अबाउट 5,000 टन की यहाँ पे एयर कंडीशनिंग की रिक्वायरमेंट है. कमर्शियल जो आएंगे यहाँ पे हमने उनके लिए मैंडेटरी कर दिया, दे हैव टू यूज वाटर कूल्ड HVAC सिस्टम्स. वाटर कूल्ड HVAC सिस्टम्स. क्या यूज करो? वाटर कूल्ड VRF लगाओ, वाटर कूल्ड DX लगाओ, वाटर कूल्ड चिलर लगाओ, आपके ऊपर है. वाटर कूल्ड सिस्टम मैंडेटरी कर दिया. जहां वो किया 4 लाख लीटर पानी मेरा रोज का कूलिंग टावर में जाना शुरू हो गया. अब वापस आइए यहां पे. अभी भी मेरी 40 लाख लीटर डिमांड है, लेकिन ये जो 20 लाख लीटर जो मैं सीवर लाइन में डाल रहा था, अब से 16 लाख डाल रहा हूं, क्योंकि 4 लाख लीटर मेरा कूलिंग टावर मेकअप के लिए जाना शुरू हो गया. ये रिलेशनशिप्स है. And I brought the energy consumption down. For 5,000 tons of air conditioning, I brought the electrical consumption down. And उसके अलावा pumping cost down. अभी we will talk about it. Then we did something different, जो आज की डेट में सिंगापुर में होता है. जब आप अपने टॉयलेट में, जब बाथरूम में जब जाते हैं, एक पानी होता है जो आप वॉश बेसिन यूज करते हैं, उसको हम ग्रे वाटर बोलते हैं, वॉश बेसिन में या शावर में. एक पानी होता है जो आप WC में करते हैं. जो सॉलिड्स होते हैं सारे वो WC वाटर में होते हैं. जो आपके पास शावर से आ रहा है और जो आपके वॉश बेसिन में आ रहा है, दैट इज व्हाट वी कॉल अ ग्रे वाटर. उस ग्रे में कोई सॉलिड नहीं होता, उसमें सोप होता है हल्का सा. राइट? यही होता है. हमने उस ग्रे वाटर को एक अलग लाइन बना दी और ब्लैक वाटर की अलग लाइन बना दी. ब्लैक वाटर को जो कि WC से आ रहा था, उसको हम एक सुवेज ट्रीटमेंट प्लांट अलग ले गए और जो ग्रे वाटर था जो कि आपका शावर से और वॉश बेसिन से आ रहा था उसको अलग ले गए, उन दोनों को रिसाइकिल किया। जो ग्रे वाटर था जो कि पानी है सिर्फ उसमें सोप मिला हुआ है, उसको क्लीन करके वापस डोमेस्टिक साइकिल में डाल दिया, उसको वापस उसी साइकिल में डाल दिया जो आप जिससे नहाते हैं रोज या जो करते हैं। और जो ग्रे वाटर था, जो ब्लैक वाटर था जो कि हमारे सॉलिड्स थे, उसको मैंने कूलिंग टावर में, फ्लशिंग में और इरिगेशन में यूज कर दिया। आप कहोगे अरे साहब वो एसटीपी का पानी आप मेरे को नहाने के लिए दे रहे हो, आपका पानी आता कहां से? बाय द वे कैनाल से आपने बोला ना जाता है। कैनाल में कभी पानी देखा है आपने कैसा होता है? आवर कैनाल्स, आवर रिवर्स आर नथिंग सीवर लाइंस, और आप वो पानी पीते हैं रोज। यहां तो मैंने सिर्फ आपका जो सोप का पानी है या जो वॉश बेसिन का पानी है, क्लीन वाटर को रिसाइकिल करके मैंने वापस डाल दिया। मेरी वो डिमांड जो 50 लाख लीटर थी, 40 लाख लीटर थी, गिर के 23 लाख लीटर रह गई। फ्रॉम 50 लाख लीटर्स वी कम डाउन टू 23 लाख लीटर्स फ्रेश वाटर डिमांड, एंड एक्सेस वाटर जो निकल के आ रहा था इज जीरो। देयर इज नो वाटर गोइंग आउट ऑफ दिस टाउनशिप, एंड ये जो 23 लाख लीटर है इज व्हाट वी नाउ स्टोर रेन वाटर एंड वी मेक दिस अ नेट जीरो वाटर टाउनशिप। हु हैज टू प्ले द रोल? ये कौन डिसाइड करेगा कि ये इस तरह की साइकिल बननी है? प्लम्बिंग इंजीनियर, एचएसी इंजीनियर, आर्किटेक्ट, क्लाइंट, ग्रीन बिल्डिंग कंसल्टेंट? Who's going to do that? This is where the energy water nexus starts coming to the picture. मेरे जो पंपिंग पावर है, इंसिडेंटली आपको बड़ा इंटरेस्टिंग एक चीज बताता हूं, मेरे पास भी 10 मिनट है। मैं बड़ा इंटरेस्टिंग बताता हूं। दिल्ली में आज की डेट में 1 full power plant is running just to pump the water, Now दिल्ली क्या होता है हमारी सिटी में, यहां पे भी यही होता है, म्यूनिसिपल लाइन है, वहां पे प्रेशर कम है। हमारे जो पानी की टंकियां कहां पे हैं? रूफ पे है। अब पानी में इतना प्रेशर नहीं है कि ऊपर तक जाके भर सके, तो हम क्या लगते हैं, लाइन में एक पंप लगाते हैं, उस पंप से अपने अंडरग्राउंड टैंक में पानी डालते हैं, फिर वहां से एक पंप लगाते हैं, ऊपर डालते हैं उसको, और फिर वहां से पानी आता है। यही करते हैं हम लोग साहब, यही होता है सबके यहाँ, यही हो रहा है, लाइन में लगे। उस पंपिंग एनर्जी को चलाने के लिए आज की डेट में मोर देन 1 पावर प्लांट इज रनिंग इन दिल्ली जस्ट टू रन दैट। 40%, somewhere I was reading, 40% of Delhi's energy is going into water pumping. Look at the energy and water nexus. This is what is called energy water nexus. More and more, this is the issue which is being talked about in the world. ये solve कौन करेगा? सागर जी करेंगे? कौन करेगा? This is the big issue that we are talking of. Now I'll tell you something else. पानी गर्म कैसे करते हो? अच्छा ये बताओ, आपके घर में पानी कहां से कैसे गर्म होता है? गैस से। थैंक यू। गैस से, चलिए 1, और गीजर से, सोलर हीटर से, चलो, और हीट पंप से। तो हाँ, वो तो हीट पंप बेच रहे हो तो कहेंगे। सो हीट पंप हो गया, गीजर हो गया और गैस हो गई। भाई 3 चीजें पानी गर्म होता है, और रोज गर्म पानी यूज होता है पुणे में, यस राइट, वैसे बंबई में भी होता है रोज। सो एम आई राइट राम? एवरी डे वी बेथ विद हॉट वाटर देयर, और ये पानी जो है नॉर्मल घर में गीजर से आता है, और जो बहुत एडवांस्ड है, आप एनर्जी एफिशिएंसी के बारे में बात करते हैं, राम और सागर, उनके हीट पंप से आता है। That's all what you're doing. This is what we are doing. Correct? And keeping you happy, यही आप बेचना चाहते हो। बट एक चीज और है, पुणे में और बंबई में रोज एयर कंडीशनर चलता है, रोज एयर कंडीशनर चलता है, और उस एयर कंडीशनर से हॉट एयर निकलती है, हीट निकलती है। How many of us talked about recovering that heat energy to generate water? Nobody is talking about it. This is our HVAC industry business. Here it is. This is the VRF unit. मैंने कंपनी का नाम हटा दिया जिससे कोई कंपनी का प्रमोशन ना हो। VRF unit, साथ में hot water being produced along with that. It is possible to do that. These recovery units are available. How many of us are using it? आप Pune is the VRF capital of India. Am I right? 99% work is done on VRF only here. How many of us recover the hot energy, which is, or the waste energy that is coming out of VRF and running hot water with that? Here is a project we are designing currently in Maldives. Maldives is all islands. We are doing a similar work in Andamans also. Andaman, Lakshadweep. Complete island. There's nothing else. There's पानी भी पीने का और एनर्जी भी सारी बोट से आती है वहां पे. 100% hot water generation is through the AC units which are running there. 100%. There is not even a single electric consumption being done for producing hot water. Look at it. It is possible to do it. We are talking of a 5-star hotel, 500 keys, hot water generation free of cost. And it is possible to do that. Who's going to solve the problem? HVAC industry, plumbing industry, or green building industry? Who's going to run it? Think about new ideas. How many of you talk about condensate from the HU collecting that? Bombay में तो बहुत condensate produce होता है. अगर मैं सिर्फ condensate बॉम्बे में उनके एयर कंडीशनर से इकट्ठा करना शुरू कर दूं तो एक लेक तो उसी से भर दूंगा. राइट राम? तो वो कहां जा रहा है पानी? इट्स गोइंग टू द स्टॉर्म वाटर ड्रेन. क्यों? क्योंकि वो प्लम्बर डिजाइन कर रहा है और एचवीएसी इंजीनियर डिजाइन कर रहा है. Who's talking about integrating it? Look at the energy that we can save just by integrating the designs. And ये आप ही को करना है. I'll show you another example. ये छोड़ देते हैं. Meters. IoT systems. आप में से कितनों के घर में पानी मीटर के आता है? बस 6 हाथ उठे हैं. पुणे में तो भी पानी मीटर होके आ जाता है. यहां पे ट्रेंड शुरू हो गया. बॉम्बे में तो अब हाथ लगा के दिखा दो मीटर को, बाहर धरना हो जाएगा. दिल्ली में हाथ लगा के दिखा दो, स्ट्राइक हो जाएगी. मीटर वाटर इज टेकन फॉर ग्रांटेड. मीटर वो कितना रेट देते हो? पूरे पानी का बिल कितना देते हैं साहब हम लोग साल का? 10,000 रुपए साल. 3,000 रुपए. 36,000 रुपीज साल का देते हैं साहब हम. और पानी का कंजम्पशन उसके बाद अनलिमिटेड है. फिर अनलिमिटेड है पानी, जितना चाहे उतना यूज करो. नाउ आई विल शो यू हियर. I came across some developer in Pune, and you can validate that. They said कि साहब they have started charging for water. Prepaid water meters आ गए हैं यहाँ पे. Am I right? There are some of the new townships which are talking of prepaid water meter. Prepaid मतलब ये क्रेडिट कार्ड डालो और पानी आएगा उतनी देर जितनी देर आपका बिजली जितना आपका मीटर चल रहा है. और बड़ा इंटरेस्टिंग है. बोलते हैं पहले तो सबको लेट अस से फर्स्ट 5,000 लीटर जो पानी या 1,000 लीटर पानी जो है आपको, वो आपको एक फिक्स रेट पे आएगा. अगर आपका उस महीने में आपने 1,000 लीटर पानी या 2,000 लीटर जो भी उसने आपको कोटा दिया हुआ है वो कंज्यूम हो गया, नेक्स्ट जो 1,000 लीटर खरीदोगे वो डिफरेंट रेट पे आएगा आपको. दिस इज व्हाट स्टार्टेड हियर. राइट? पानी इज बिकमिंग एक्सपेंसिव नाउ. आज की डेट में हम सब टॉल बिल्डिंग्स बना रहे हैं. और हम क्या करते हैं नॉर्मली? हमारे जो पानी के पाइप्स होते हैं वो सारे के सारे हमारे चलते हैं. ये टॉयलेट शाफ्ट होती हैं हर एक हमारे बेडरूम में. आई थिंक जितने हमारे डिजाइन के लोग हैं वो ज्यादा समझेंगे इसको. हमारी कई सारी शाफ्ट होती है. हर टॉयलेट के साथ एक शाफ्ट दी जाती है जहां पे पानी का पाइप उतरता है. करेक्ट? हर घर में और 3 शाफ्ट जरूर होती हैं. एक किचन के साथ होती है, 2 बाथरूम के साथ होती हैं. उसमें पानी का पाइप नीचे उतरता है. मेरे को अगर वाटर मीटर करना है तो मैं क्या करूंगा? जाके उन 3 शाफ्ट में जाके लगाऊंगा. अब जो नया कॉन्सेप्ट आ गया, वी आर टॉकिंग ऑफ वाटर मीटर्स. जो लॉट ऑफ न्यू डिजाइन, लॉट ऑफ न्यू प्रोजेक्ट्स दे आर डूइंग. दैट इज जैसे बिजली आपके सेंट्रल उसमें कॉमन एरिया में उतरती है, पानी भी कॉमन एरिया में उतरना शुरू हो गया और पानी को मीटरिंग शुरू कर दी गई है वहां पे. दिस हैज स्टार्टेड इन दिल्ली, दिस हैज स्टार्टेड इन पुणे, दिस हैज स्टार्टेड इन बॉम्बे, दिस हैज स्टार्टेड इन हैदराबाद. दे आर ऑल गेटिंग रेडी फॉर वाटर मीटरिंग. Why I'm bringing this is because water is going to become more and more dear as we go forward. Energy is going to become more and more free as we go forward. जैसे जैसे हम renewable energy की तरफ जा रहे हैं, energy costs coming down, and what is going up is the water cost going up. And wait and watch तो trend शुरू हो गए हैं इसके अंदर. We are now talking about aerators to be installed in the. आप में से कितने लोग होटल्स में गए हैं जहाँ पे टैप खोलो तो पानी जरा सा पानी आता है? Why? Because they are talking about now water meterings being done there, and lots of such things are happening. And if you look at the net zero water rating system of IGBC or USGBC, they talk about the same thing. First, they talk about reduce the water demand. Second thing, they talk about use recycled water as far as possible, and then talk about water being absorbed back into the ground. Fourth thing, they talk about this innovations that can be done, and this is what the net zero water rating system is all about. We came out with I was a chairman of this rating system and chairman for the energy rating system. And I'll tell you, आज की date में energy rating system is doing, net zero energy rating system is so well, and net zero water rating system के लिए there are no takers at all. Look at the irony that we are running with this point of time. This is what I wanted to talk about. And I have always said that I always used to say net zero energy buildings are a mindset change on how we design, construct and operate building. Forget that energy word. Now I'm saying net zero buildings, whether it's energy or water, they require us to start thinking differently if we want to design a real building. और आप सब उसका part बनेंगे because water is something that we are running out of. This is the last slide I want to show of something importance. Last year बहुत बड़ा एक event हुआ था जिसका telecast हुआ था, कई news channels ने उसको capture किया था. One big ice shelf from Antarctica broke. That ice shelf was the size of Los Angeles. It broke and it dissolved, and that's what happened. And when it happened, it became a big event. Imagine when all of the ice one day is going to melt, which is not far away, 2040, 2050, we are talking about it, ice will finish. Imagine at that point of time what we are talking about. I was reading something very interesting. There's something called a permafrost. How many of you heard about permafrost? They say permafrost is like जो कई सालों से हमारी frozen ice है, और वो तब से जब डायनासोर्स होते थे या उससे पहले जब अर्थ फॉर्म हुई थी, जिस दिन वो परमाफ्रॉस्ट मेल्ट होना शुरू हो गई, that is going to submerge the world also going forward, because that volume when it will get released. And more than that, they say उस पुराने ज़माने में जो बैक्टीरियाज और वायरसेस और जो होते थे, they are all frozen in that. What gets released, we don't even know what will come out of it from there. And when that happens, it can even be a humankind looking at a new crisis. आपने COVID देखा? Get ready for COVID came from animals. Get ready for something new that can come when the permafrost start melting out there. This is what the scientists are talking about. None of you know about this because we don't talk about water at all. This is our environmental footprint. ये एक इंसान का environment footprint है. जब हम कहीं जाते हैं, जुहू बीच पे जाओ, चौपाटी जाओ, ये हमारा footprint होता है. और जब animals जाते हैं बीच के ऊपर, तो वो उनका footprint होता है. This is how we leave our footprint behind. This is what the Mother Earth thinks about us. Am I right? अगर बोल सकती होती है, तो ये बोल दी आज की डेट में. Water and air are two essential elements. और ये दोनों आज एक garbage can है इंडिया में. ना आप नदी में नहाने जा सकते हैं, ना आप एयर को ब्रीथ कर सकते हैं. मुंबई भी उस कैटेगरी में आ गया है, क्योंकि आज फिर मोस्ट पोल्यूटेड सिटी कौन सी है वर्ल्ड की? इज मुंबई राइट नाउ. You're back into the news for all the wrong reasons. Try going into the sea. Nobody wants to go into sea. Nobody wants to go into the river. Garbage can. सच्चाई क्या है? इंसान यहां रहता है, जानवर वहां रहते हैं. यही सच्चाई है आज की. हम डेवलप्ड है ना, हमारे पास ब्रेन है, इसलिए हम यहां रहते हैं, और जिनके पास ब्रेन नहीं है वहां रहते हैं. You have a choice. You can make excuses or you can make it happen. आप आज भी ये बोल सकते हो, सर ये सारा जो बोला, सर मेरी प्रॉब्लम थोड़ी है, मुझे तो एसी बेचना है, एसी लगाना है. तो किसकी प्रॉब्लम है वो? Who's going to talk about the integrated design? मैं आज भी एक क्वेश्चन कई जगह अपने ऑफिस में पूछता हूँ क्वेश्चन कि ये कौन सॉल्व करेगा? मेरा प्लम्बिंग, मेरे पास मेरे पास एडीपी है और सबके पास ही होता है आज की डेट में। एचवीएसी वाला अपनी रिपोर्ट लेके आता, सर देखिए मैंने ऑप्टिमाइज डिजाइन किया 600 स्क्वायर फुट पर टन। प्लम्बिंग वाला, सर देखिए मैंने बहुत ऑप्टिमाइज कर दिया। और इलेक्ट्रिकल वाला भी वही दिखाता है, सर ये चिल्लर मेरा, ये मेरा ट्रांसफार्मर सिलेक्शन। बट उनमें से कोई आपस में बात नहीं करता। None of them talk to each other. I don't know आपके यहाँ क्या होता है, मेरे यहाँ नहीं बात करते ये लोग। वो 3 डिपार्टमेंट एक 3 कंट्रीज की तरह है। But let's remember, size of the steps do not matter. हाँ, सेम थिंग हमारी कॉन्ट्रैक्टिंग में होती है। HVAC कॉन्ट्रैक्टर अपना करेगा, प्लम्बिंग अपना करेगा, इलेक्ट्रिक अपना करेगा, and we are gone. Nobody is worried about of doing this. So size of the steps do not matter. Is the step forward is forward, and this is what the true sustainability is. When we start doing a integrated design going forward, start thinking about the impact of our design on others, and that's what will solve the problem going forward. Thank you very much. It was a very different topic. It took a lot of struggle for me to prepare this, and took a lot of experience. I needed 1 hour, Anup, so I couldn't help it there. It took a lot of time for me to think in this direction, because even मेरे यहाँ भी इतना सब करने के बावजूद, ग्रीन टीम होने के बाद, HVAC होने के बाद, इलेक्ट्रिकल प्लम्बिंग के बाद, I am not able to integrate these people. And this is the real story of our industry. And we have a solution. We have a solution for water, we have a solution for energy, we have a solution for everything available if we start doing the building designs right going forward. So thank you very much. Have a great evening, everyone. So I think that's been something I've been asked a lot of times. Who makes your slides? Where do these? So I have a bunch of people, youngsters, जो शुरू की स्लाइड तो वो देते हैं, जो 8, 10, 15 स्लाइड जो शुरू की होती हैं, उसके बाद की जो है हमारी रिपोर्ट की कट एंड पेस्ट है सारी. So that's my job to put my thoughts together. So I was up since 6 in the morning today till about 9:30, 10. I was just cutting, pasting from my various projects and making the presentation, because this is something I've never presented earlier. So that's why it took me a little time to do that. Thank you.
Intention and the urge for this problem is very honest. So I would request Mr. Arvind Surange sir to kindly felicitate Mr. Ashish Akheja sir.
Started doing new in design, and I'm looking for somebody to critique it, especially the youngsters who are sitting here. In a central plant job also, of course I can get a hot water recovery from there. We've started putting a small VRF or a DX unit now in a central plant job just to generate hot water from there. So जो 24/7 areas होते हैं, जैसे back of house areas हो गए होटल में या हॉस्पिटल में कुछ एक एरिया हो गए, we put that and generate hot water for the entire hotel just from one VRF unit now. So,
Thank you. Now we have 3 honorable guests who are arrived, and I would now request Mr. Nandkishore Kotkar sir to kindly felicitate them and to please come on the stage. So first we have Mr. C. Ramachandran. I would request them to kindly come on the stage. K. Ramchandran, okay, it's my mistake. Mr. K. Raghavan sir. Request him to kindly come on the stage. And at last, we have Mr. Kishore Karle sir. I request him to kindly come on the stage. Thank you so much, sir. So I would now like to call upon Mr. Ritesh Khera sir to speak regarding industrial visit for ISHRAE members.
गुड इवनिंग, नमस्कार। जैसा आशीष सर ने बताया, इंग्लिश से ज़्यादा हिंदी बोलने में मज़ा आता है। सो उन्हीं की लाइन पे मैं भी चाहूँगा कि हिंदी में ही बात करूँ, थोड़ा बहुत डेफिनेटली इंग्लिश तो आ ही जाएगा। जैसा आशीष सर ने हाईलाइट किया रिगार्डिंग वाटर कंजर्वेशन, और हम लोग यहाँ ISHRAE में हर सेशन में, हर टॉक में एक वर्ड जो सबसे ज़्यादा सुनते हैं, दैट इज सस्टेनेबिलिटी। और एक स्लाइड आशीष सर का जो दिमाग में रह जाता है कि आइदर यू कैन मेक एक्सक्यूजेस और यू कैन मेक इट हैपन। एंड दूसरा जो उन्होंने बताया, इंटीग्रेटेड सॉल्यूशन, इंटीग्रेटेड डिजाइन या इंटीग्रेटेड अप्रोच। हम लोग इंडिविजुअली बात करते हैं रिगार्डिंग सस्टेनेबिलिटी, या उसके ऊपर कुछ एक लोग काम भी करते हैं, बट क्या आप लोगों को पता है कि पुणे के काफ़ी पास में एक छोटा सा गांव है, जो पूरा का पूरा गांव इज वर्किंग टूवर्ड्स द सस्टेनेबिलिटी इन अ बिग मैनर। बहुत अच्छे लेवल पे वो लोग काम कर रहे हैं, एंड इट हैज़ गॉट वेरियस अवार्ड्स, इवन प्रेसिडेंशियल अवार्ड तक उनको मिला हुआ है जो लोग काम कर रहे हैं। एक छोटा सा वीडियो हम लोग प्रेजेंट करना चाहेंगे। टाइम लग रहा है, सॉरी। तो तब तक एक थोड़ा बहुत बता देता हूँ। दैट विलेज इज कॉल्ड टिकेकरवाड़ी, एंड इट्स इन जुन्नर तालुका। यहाँ से अराउंड एक 100-125 किलोमीटर के आसपास है। एंड उनको लास्ट ईयर ही प्रेसिडेंशियल अवार्ड मिला था फॉर देयर एनर्जी कंजर्वेशन, या उनका बायोगैस प्लांट्स, RO प्लांट्स जो गांव के लेवल पे बना है, नॉट एट इंडिविजुअल लेवल बट फॉर एंटायर विलेज। तो उसका हम लोग एक विजिट और अरेंज करने वाले हैं फॉर ऑल द ISHRAE मेंबर्स, एंड आई एम श्योर इट मस्ट बी अ वेरी डिफरेंट और बहुत ही एक अच्छा लर्निंग रहेगा फॉर ईच एंड एवरी वन। सो वी वुड लाइक कि आप बड़े नंबर्स में आए। इट्स अ गोल्डन अपॉर्चुनिटी। ये 2 नवंबर थर्सडे को प्लान किया हुआ है, एंड विल सून सेंड द फ्लायर्स एंड ऑल। सो जस्ट गो थ्रू द वीडियो। ये थोड़ा पुराना वीडियो है, बट all the things they've done already.
ज़मीन नहीं थी तो विलेज के लिए पेड़ लगाने के लिए, तो हमने कुछ बंजर पड़ी हुई ज़मीन थी जो बहुत से किसानों की थी, उनको इकट्ठा किया और उनसे हमने रिक्वेस्ट की कि हमें ग्राम पंचायत को ये ज़मीन दीजिए, इसमें हम फल लेने वाले पेड़ लगाएंगे।
पवन चक्कीमुळे ग्रामपंचायतीमध्ये स्ट्रीट लाईट, कॉम्प्युटर आणि पंखे चालतात।
हमारे पास नैसर्गिक साधन संपत्ति है, विंड भी अच्छा है और सोलर रेडिएशन भी अच्छा है, इसके ऊपर हम इलेक्ट्रिसिटी जनरेट कर पाए। हम हमारे खुद बिजली बना रहे हैं और खुद खर्च
त्या फिल्टर पाण्यामुळे आम्हाला आता आजार पण आमचे कमी झाले। मुले बाळी पण आजारी पडत नाही. ते पाणी वापरून पैसे मिळता येईल ते खूप काय
जो भी माता लड़की को जन्म देगी उसको ग्राम सभा में उसका ऑनर करेंगे, उसको सत्कार करेंगे. हमारे गांव के 1000 लड़के के पीछे 1081 लड़कियां हैं.
स्मोकलेस विलेज करायचं आमचं एक उद्दिष्ट आहे.
हमारे जो भी एकजुटता है, भाईचारा है, इसकी वजह से हम ये कर पाएंगे. ये गांव हमारा है, हमें खुद काम करना है. और हम खुद काम करेंगे तभी हमारे गाँव में सुविधा है.
Thank you. So, thank you very much. 2nd November, Thursday, we have organized a visit to Tikekarwadi. We will soon be sending the flyers. So please join in big numbers. Thank you, and thanks a lot for accommodating.
Thank you. So I would now request founder of Fount Lab Solutions Private Limited, Mr. Neeraj Magnani, sir, to proceed with his presentation.
Good evening, everyone. The world's most valuable asset isn't oil. It isn't even data. It's real estate. See why I say that, and please hear me carefully. The reason is over the period of years, the trends that we are seeing in our country is more and more number of people are coming to cities. There is a tremendous growth in the urbanization in our country. Now, if we want to sustain this growth of urbanization in our cities, what becomes important is how we manage our buildings. Managing our buildings is the most important thing that we need to take care and we need to concentrate. Because otherwise, how would we be able to talk about energy conservation and all those things? So the urbanization at its hit in the city, if we do not manage buildings, it's going to be a disaster for us. Good evening, friends. My name is Neeraj Magnani. I am founder of Fount Lab Solutions, and we are a technology-driven startup, a government-recognized startup. And we are focused and head-focused on transforming the building data into a valuable asset. So that is what we are into. I'll just brush through and run through our slides. So what we are, like I said, we are a technical company. We design our own electronics in-house in India with love in Pune. From electronics to the cloud application and to the AI, we have everything in-house. We started our journey in 2019, and we are proud to say that we are one of the government-recognized startup working in the area of energy conservation, water conservation, and air quality monitoring. So what exactly we do? I'll just run through these slides because we have a limited time over here. What exactly that we do? We do a very simple thing. The assets and all those things in a particular building are available in a disparate system. We just do a very simple thing. We provide a uniform system, a unified blanket, from where a one-stop solution from where you can achieve the lower operation costs. So most of the things are written over here. I do not want to repeat those things. Now, this is what we do. what is the next question that would come is, why are we doing that? See, if we understand that 40% of the energy consumption is from the commercial buildings, okay, that's fine. But in the last 40 years, if we see, there has been a lot of development in terms of the hardware, the mechanical hardware in terms of energy efficiency, but there has been a very, very limited way, a very limited thing, a data-driven approach to save and conserve. And that is where, as a technical startup, we think our capabilities, we target those things, and that is why we are doing it. There has not been a lot of focus on software and data-driven way of solving the problems, because there are experts in all those things, right? But the problem is the data-driven way is something that can at least save 20% of energy for us. And now how we do it in a very simple way. Like I mentioned, we have our own electronics. We design our own electronics in-house. So we make our electronic devices wireless, battery-based devices, which you can install and commission in a very easy way. And they straight away start transmitting data to the cloud where you can do the analytics. The beauty is, if there is an expert who is sitting over here in Pune and the plant is in Kolkata, the expert can from here right away see what's going on. I'll try to show that a few examples if possible. So this is our team, not dwelling much on the team. I love my team. So next is, these are some things which we already know. I do not want to dwell on these things. I'll go to the next slide to make you understand what exactly our technology is doing, or the offerings that we have, basically. So this is what we have: the building, we collect the data, blah, 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 what I already mentioned. Let's go to the next slide. So we have our own devices, like I mentioned, battery-powered devices, wireless devices. All those devices, we have a stall over here. You can see that, you can check that. All the devices and sensors right over here, Fount Lab stall. You will understand on our stall that we actually have taken a lot of effort to do these things in the last 4 years. So yeah, wireless devices is our strength. These are a lot of sensors that we do, but not limited to these things, okay? And yeah, so this slide is basically what it's trying to say is that ASHRAE is our IoT cloud platform. And in that IoT cloud platform, these are the sensors that you're seeing over here, okay? And then there are these controllers. There is no meaning just by sensing. It is very important that after sensing, you need to control as well, okay? Now the controlling part is something, the PLCs, so you might think, okay, we might be taking PLCs from someone else. No, but these are the PLCs or the IO controllers that we design. This is completely our design. And then once we do the measurement and the controlling, what becomes important is to analyze. So that's why the cloud is required. So this slide will just let you know, okay, what all things we have done, but you can see those physical devices placed over there. Now this is our cloud application. Again, no point in getting into this because of limited time that I have. I'll try to show some demonstrations which we have done for the clients. Yeah, so basically sense, control, analyze, again, that same slide. I am bringing this slide again so that you concentrate more on this thing and not here just to me. So yeah, so what we have done is we are working like Ashish sir was mentioning. It is very important that to become sustainable, air, water, energy needs to be measured. Measurement is the thing, only after that action can be taken. Otherwise, there is no meaning. And a study says that the people who operate the building, okay, they do not know where they're spending the money. And according to the report, 25 to 30% of the money is wasted because they do not have an idea. Now this is our engagement model, let's not get into it, but yeah, we are open to these kind of engagements. These are our customers as of now, and we are growing strong. It's a good thing for a bootstrap startup to reach to a particular level like this in 4 years, gone through the corona as well. This is our R&D facility, the place where we design. And like I said, I am very proud of my team. They are with us for the last 4 years, and I really love my team. So, yeah, so this is the presentation. Now what we will try to do is, yeah, I'll give you one example. So this is an example, a dashboard that we were trying to give to GMR. What I want to tell you over here, right now what you can see is the STP, but let's go and see the, yeah. So you can see the energy drawing from the one simple slide as well. Now the UI, the best part is the UI and everything can be configured as per the client. It's not a static thing that we are providing, okay? Now that's the beauty of our systems. And so, yeah, so let's go ahead and let us say we want to see the STP management, so we can see the STP related stuff over here. And then let's say, like Ashish sir were also mentioning about the waste management. So if you want to do the waste management, you can see what's going on, how many bins of your are empty. And you know, now these are battery based bins, probably. Similarly, if you have a fleet inside your factory, you can see those fleets inside, you know, where the fleet is. This is just an example that I'm showing. But now let's do one thing. Yeah. So this is basically one of our tool was used for auditing the energy. So basically we have an interface done for client where we can show everything, but I do not have permission to show it. So what all permissions I have, I'm just trying to show you all those things. But this is essentially one of our device that was used for auditing the AHU. Now here what we can do, so I'll just try to do one thing, show you one thing. We can go to any time period that we require. Over here, let me go to, let us say, August. From August 5th. Now, because this is Internet of Things, my laptop needs to have internet, otherwise it won't work. Oh, okay, no problem, it works. So what I'll do is, I'll quickly So what I'm trying to do parallelly is trying to show you that we can select the parameters that we require. Now this is nothing but water flow rate in the coil of the AHU. Now the experts would understand what's going on. We are not the experts, but this is a platform for the experts so that they can remotely do the audits of their clients. And then similarly you can see the supply at temperature or return at temperature, the way it has followed. Duct velocity also you can follow. It depends what all sensors that we are installing. Just to give you an idea, the analytics can be done. Also we can download all this data, you know, in the CSV format or Excel format. So that's one thing that we can do. And of course we can visualize and analyze the data the way we want. That is one about the AHU. So similarly for Ashish sir was also mentioning about STPs. The STP monitoring is a little bit really important. So because he mentioned about STP, I thought, you know, bringing this thing also in front of you guys. So this is one example of a site. So what I'm showing over here is all your plants or everything, we can place it on the map. You go on the map, whichever site you want. See the complete thing is actually customized. Now over here, then we can go to the parameters and all those things. And over here right now, so we have installed a IAQ device at our stall. And right now we can see the actual values of the IAQ. I think CO2 is more important. So over the period of time, if you see, the value of CO2 is increasing. Because right now, probably we are at peak of the audience. Okay, and if somebody is feeling, excuse me, if somebody is feeling dizzy right now, okay, that's completely valid, that's completely right. It's not because of my boring speaking, but it's because of the CO2 level that you can see over here. It's quite at a higher level, but not at a very bad level, I would say, you know. So the analytics and all those things can be done. In the similar way, I would like to show you one good example. So this is a IT park. This is very interesting now, and this is my last 2 minutes. So please be with me. So this is basically a IT park. And it has, so we have installed IAQ monitoring devices in this IT park, and they are placed at various different locations. So the complete building is divided into Block A, Block B, and Block C. And these are the number of parameters that you can see that we are monitoring. It's a total, it's as per the IGBC and ISHRAE norms. So now I go to Block B, I can go inside Block B and see what's going on. Inside Block B, I can go to the detail thing. So this is the complete floor, the elevation plan. And these are the number of devices that have been installed at different locations and different floors. We can just go to any device to know instantaneously what its value is. Okay, I can see its instantaneous value right now. Over here you can see the last reading was at 8:53, yeah, so just 2 minutes back. So it is actually almost near real-time data that we are seeing. Now the interesting part is, so if we go, now this is the Block B average data that we are seeing over here. Okay, now see the interesting part. The yellow color is the CO2. Okay, this is the CO2 value, and you can see the peaks. Okay, so interestingly, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, you know. So this is what, with the data, we can live see what's going on. Okay, now the experts can actually take their call, what needs to be done, how it needs to be done. Similarly, we have other parameters as well. So this is very important. From here we can understand. So we observe when it is Diwali. Last year when it was Diwali, there was long time where the CO2 was low. Anyways, I have limited time, but basically we are available at our stall. We would welcome you all to please visit our stall and let us know how we as a startup company can contribute to this field of HVAC. We would be really wanting to have a conversation with you guys. Thank you. Thank you.
I would now request Mr. Amit Gulavde sir to kindly felicitate Mr. Madnani sir. So I would now like to call upon Mr. Ganesh Raskar sir from Asava Insulations, who is working in HVAC field from last 9 years as a sales and marketing professionals and is now working as senior sales manager at Asava Insulation. So let's welcome him with a round of applause.
Good evening, everyone. I am delighted to have the opportunity to speak to you today about an important topic that holds immense significance for our environment and our future. In an era where sustainability and environmental consciousness have become a paramount, green products are leading the way towards a more sustainable and eco-friendly future. These products are designed with a...
We manufacturing from 13 mm to 75 mm. Depending upon the application, we suggesting the thickness of the panel. Advantages of the PR panels. The smart PR panels have the lowest thermal conductivity. it's a anti-rodent product. It's a rodent-proof product. Life of PR ducting is more than 20 years. Related to fire, it's a class O product, anti-rodent, fire retardant. It can be sustained 2 hours to 50 degrees Celsius. It's environmentally friendly. It's a CFC and HFC free. Because of the aluminum surface on the both sides, there is no corrosion happen in the pre-insulated ducting. Water absorption is very negligible. It's a 0.03% water absorb. After 24 hours, water fall on the panel. Fungus growth is very low, less because both sides will be the aluminum foil. So there is no fungus growth. Applications of the panels, major application is the ducting application. It's a replacement of GI duct with insulation. Second application is underdeck or overdeck insulation. Third one is false ceiling, and fourth one is cavity wall insulation. 5 PR ducting is better than the GI ducting with insulation. So some points we have given here. It's a CFC and HFC free, recycled content, lower carbon footprints. In pre-insulated ducting, there is a very low leakages. Thermal conductivity of the PR panel is world's lowest. It's a 0.21 watt per meter Kelvin. The foil which are using in the PR panels, it's a antimicrobial and antifungal. Our panel is Green Pro certified and GRIHA certified, having the lightweight product. Energy conservation and lead time is very less. Transportation cost is also very less. Project completion time is 4 times faster because there is no need of insulation. It's an insulated product. Cleaning and maintenance is very easy. Fire rating is 2 hours to 50 degrees Celsius at delta 30. It saves very low space, non-toxic and non-carcinogenic, and low VOC emission, UV resistance. This is our world's first patented PR flat hole duct. Recently we have developed this, I guess 3 years back. It's a replacement of GI ducting with spiral flat hole duct. There is no need of insulation again in this case also, because here also you are using the PR panels. So it's a very lightweight product. It can be paintable, cleanable. We have received a recent some awards. Iconic brand of the year 2021. Again in 2021 winner India SME 100 awards by Indian SME Forum. And again in 2021 we have received the Super Indian brand by People Choice Awards. And in 2022 we have received Times Visionary Awards. And this is our client list. Thank you so much. If you have any doubts, please visit our stall. Thank you so much.
I now request Mr. Amit Gulawde sir to kindly felicitate Mr. Magnan. Okay, Ganesh, okay, sorry, so sorry. I would now request Mr. Shashidhar sir to kindly felicitate Ganesh Raskar sir. Mrs. Viju Bhatia ma'am from Srirang Automation and Controls to kindly deliver a presentation. She is an electronics engineer and MBA and has joined as managing partner in Srirang Automation and Controls in 2016. So let's welcome her with a round of applause.
Good evening, everybody. I know it's been a long day. I'll make it quick. Thank you. Presentation, please. Yeah. I'm from Srirang Automation and Controls. We have our stall in the corner of the hall. Request you all to kindly visit us. We have a lot of products there. Srirang Automation is part of Puja Group. I'll just quickly run through. We are panel builders. We manufacture control panels. IEC certification is in process. We are a master distributor for Doyer. Doyer is an American brand into the input sensors. There is a lot of variety of Doyer, which is about 4,000 products. These are the key markets. Here, HVAC and BMS is the major market. This is a very famous product of Doyer, which mostly everybody in the HVAC industry would be aware of. This is like what a photocopy is to Xerox. So people don't call it a differential pressure gauge, but they call it a Magnehelic gauge. These are the various switches and sensors used in the air handler. This is the entire range, and all the products come with a 5-year warranty. These are products with the chillers. I would especially like to highlight the insertion electromagnetic flow meter. This is a very unique product. It has won a lot of awards. This is one size fits all. So this product is for 4 inches of pipeline size to 36 inches of line size. This is various thermostats and switches and sensors. Clean room, we are very, very popular in the pharma industry. That's it. Thank you from my side.
I now request Mr. Ulhas Vatpal sir to kindly felicitate Bhatia ma'am. Product presentation video by our gold partner for society here by Testo. So can you please play the video?
From the transportation of refrigerated and temperature sensitive foods to the production and logistics of pharmaceuticals up to the reduction of CO2 emissions, measuring instruments and solutions from Testo provide security. Because only precise monitoring and measurements give you the certainty of complying with legal regulations and guidelines. This is how we at Testo contribute to increasing the quality of products and services, protecting human health and the environment, and conserving resources. To this end, over 3,000 employees worldwide develop high-precision measuring instruments and innovative solutions for digital data management for over 1 million customers. Because these are objectives that motivate us all. Join us so we can grow together.
So I would now request Mr. Subodh Murkewar sir to felicitate Team Testo. So Team Testo, kindly come on the stage. Team Testo, kindly come inside.
Next
So We now have the felicitation of our gold partner, Hariom Industries, and I would like to request Mr. Shamkan Mirasi sir to kindly felicitate Team Hariom.
Team Hariom. Mr. Ketan Panchal. Mr. Ketan Panchal, जल्दी आ जाइए. तो टीम जल्दी आ जाइए.
I would also now invite our own society or insulation partner, Armaflex and Shri Jashraj Enterprises, and I would request Mr. Ritesh Khera sir to kindly felicitate them.
Now request to Arvind Surange sir, Paranjape sir, Mukund Ranade sir, and Riswadkar sir, please come near the dais. Ashutosh Joshi sir, Virendra Borade. Sir, please come on.
Welcome, sir. Ramjan sir, Balami sir, please do come. Hello. Ramchandra sir, Balami sir. Ashish sir, somebody may be outside, please call them. Yeah, this is a ACR trend which started 2005-06. That team, everybody is here, my mentor, guide, guru. After their thoughts and they supported fully, we were zero. उसके पीछे एक लगाने का काम ये लोगों ने किया है. That's why I am here. I will not talk much about the ACR trends. Videos and series are available. And now, present President Kotkar sir, immediate past President Borade sir, Ramchandran sir, and Ashutosh, he is taking next year. This chain reaction goes up and up. This is my little brainchild idea, but like भगवान कृष्ण का माता कोई अलग है जेल में, लेकिन यशोदा मैया ने संभाल के इतना बड़ा किया. ये सब लोग ऐसे ही हैं और चलता रहेगा. Next year will be 20th. We are very happiest person in this platform. Always go ahead like team.
नमस्कार. हमारे सुहास देशपांडे इन्होंने ये चालू किया था अब 19 years or 18 years now. As the name implies, ACR Trends, the project is designed to present the latest trends in the industry. And I think that was the main purpose of it. And since morning, we have witnessed this. That we have always, seen people presenting the latest trends in the field. So that was the main aim of this particular project. And I thank Suhas for starting this. Thank you.
Our current president only has given me one condition. I have to give present to everybody. So it is here.
Okay. Surang sir.
And is already our guide. Ramchandran sir. Industry 4. This way, ACR Town will go digitally. The fourth version will come. We will have now startups and every idea. And last one, which is under Industry 4, I will give to Parante sir through our president. Thank you for your patient support. It is now dinner time. All the best. Event is going on. Thank you, sir. Thank you, everybody.
Thank you.
So, ladies and gentlemen, I hope that today's session was very useful to you all, and I'm sure that every participant has some takeaways from today's session. So, the success of today's event reflects the true potential and incredible work Sir has put in, and so this is the felicitation of convener. Now, I would like to call upon Mr. Subhash Kanade, sir, who is the convener for today's event. So let's welcome him with a big round of applause. And with this, I would request Mr. Manish Gulalkari, sir, to felicitate him. As we come towards the end of ACR Trends 2023-24, let me remind you all that an event like this cannot happen overnight. The wheels started rolling weeks ago. It requires stringent planning, perfect execution, and a bird eye for details. All of this is possible only with a dynamic team. And on this note, I request Mr. Ashutosh Joshi, President-elect for Society Year 2023-24 of ISHRAE Pune Chapter, to propose the vote of thanks.
Thank you, Roshni. Before vote of thanks, I would like to call upon stage Ms. Roshni Godbole. She has done fantastic MOC today, and really proud of her. And she is our ISHRAE student chapter representative. I would like to ask Mr. Ashutosh Joshi sir to felicitate her, please. Thank you, sir.
Good evening all. I think it was a wonderful time today. Without taking much time, I'll just express my vote of thanks. On behalf of ISHRAE Pune chapter, I take this opportunity to thank one and all present here, and also thank you for your patience. I thank all the speakers, presenters, dignitaries, and partners who have helped us to make this program a success. Thank you all, and please now join us for fellowship and dinner. Thank you.
Ladies and gentlemen, the bar is open now. Who want to purchase ISHRAE t-shirt or shirt, वो कोई भी हम CW से मेंबर को कांटेक्ट कर सकते हैं. ISHRAE white shirt and grey t-shirt.